Hi everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher, and today we are going to do day 5 of physical chemistry, and this is going to be a closing point of physical chemistry where we are going to do redox reactions and electrochemistry, right? So both are very linked to each other, right? If you don't know redox, then you will not be able to solve electrochemistry, right? And there are some questions, right, of redox reactions that are directly asked to you. Usually students skip redox reactions, but it is also a very, very important chapter. I'm going to give you a quick recap of the chapter firstly. Right after that, we are going to solve the previous year questions. So everybody in the comment section, let me know if I am visible and audible to all of you. Yes, everybody. Nalini, Shinchan, Shubham, Harish, Ajay, Deva, Joseph, everybody, if I'm visible and audible to you, then let me know in the comment section so that we can start with the chapter. So from 11, from I think 12, I think 11:30 a.m. something, I started preparing the notes for you. Right today in the morning, I was just preparing the notes for you. It took me a lot of time, right, to summarize everything into just 1 to 3 4 pages, right? So let me know in the comment section if you are excited for this, because I have already prepared really, really amazing notes for you, something like this. Okay, I've already prepared them for you. We are going to do a quick recap on that. And firstly, let me know if you want to do redox reaction firstly or you want to do electrochemistry firstly. So according to that, I'll start, right? If you want to do redox reaction, type R in the comment section. If you want to do electrochemistry firstly, type E in the comment section. I'll see which is more. According to that, I'll start with that, right? Okay, yes. Everybody, E or R. Okay, so let us see in the comment section how many votes you are giving to electrochemistry and how many votes you are giving to redox reactions. Redox, electro, R. Mostly I can see redox reactions only in the comment section, right? Okay, very rarely I can see E in the comment section. Chalo, I thought you will say electrochemistry in the first go. That's why I picked up electrochemistry. But as you are saying that, ma'am, we want to do redox firstly. Redox firstly, so I'll start with redox only, right? Okay, so I'll start with redox only. I think there is a mixed kind of things in the comment section. Yes. Okay, I can see E also now. I can see R also now. So I'll just pick one. Okay, I'll just pick one. Okay, pick my right hand or left hand. According to that, I'll tell you. Right hand or left hand. I have chosen one. You tell me left hand or right hand. According to that, let's give it on God now. What they want us to start. Right? Right hand or left hand. Let's play a game here. Right? R for right or R for redox? Right? L. Most of you are saying L. L was for electrochemistry, by the way. L was for electrochemistry. Chalo yaar, I think you guys are giving me so much confusion. So I'll start with redox reaction firstly, then I'll start with the electrochemistry part. Okay? Understood? Chalo, everybody in the comment section, let us start with the redox reaction first. After that, we'll start with the electrochemistry. Now, let's have full energy in the comment section and I'm going to start this, and with no break, I'm going to finish firstly redox reactions. Okay. So first thing is redox reactions. If you talk about, we need to understand the oxidation number here. Right. So for that simple things, I'll just summarize few things for you. If you talk about the oxidation number of any uncombined element, right? Any uncombined element, that means the oxidation number is going to be 0. For example, oxidation number of sodium when it is in the solid form, not in the cationic form, it is 0. Right. Next is the oxidation number of monatomic ion. Right. Monoatomic means if you talk about an ion which has -1 charge here, which has +1 charge here, then that will be equals to the charge on the ion. If I talk about, you have Mg2 positive, then the oxidation number of oxidation state or oxidation number of this Mg will be +2. So that means if you have an ion which is monoatomic, that means only one atom you have in that ion which has some charge over it, whether it's positive or negative, according to that charge will be your oxidation number, right? Okay, next is the more electronegative element in binary compound assign the number equal to the charge it would have if it were an ion. That means they are saying that if you have a compound, let's say you have HF, okay, let's say you have HF. Now, which is more electronegative? Hydrogen is less electronegative, fluorine is more electronegative. That is why fluorine belongs to halogens. Halogen have a plus one halogen has a tendency to gain one electron. That is why its oxidation number is -1 and this is +1, right? This is what you're going to predict in a compound, right? Next is the oxidation number of fluorine is always -1 because there is no other element. Fluorine has electronegativity 4. There is no other element, no other atom which has electronegativity more than fluorine. So always it is going to have the maximum electronegativity, that is -1. So always and always fluorine will have -1 oxidation number, right? Next is oxygen has, now oxygen can vary the oxidation numbers, right? Okay, so oxygen has -2 oxidation number in general. Mostly oxygen will have -2, but in superoxide and peroxide it will change its oxidation number, right? Unless it is combined with fluorine, in which it is +1 or +2, right? Okay, now let us see what is +1 and +2. If you talk about it is in the peroxide state, it is -1. Basically, guys, they are talking about that if you talk about H2O2, if you talk about H2O, here oxygen is having -2. Right? If you talk about H2O2, which is something like this is oxygen, oxygen, this is hydrogen, this is hydrogen, right? So how we actually calculate the oxidation state? Now this oxygen is bound to 2 atoms. Now if you understood this, that means redox reaction is going to be very simple for you. Oxygen is bound to 2 atoms here. This is the same atom, that means there is no electronegativity difference in this case. But here there is electronegativity difference. It has more electronegativity, so it will be -1, it will be +1. Similarly, here it will be -1, it will be +1. That is why in H2O2, the oxidation number is -1, right? Okay, that is why here the oxidation number is -1. Now, very interesting thing here, that ma'am, why over here the oxidation number is -2? Because of this structure, as you can see here. Because of this structure, I am explaining you with the help of a very simple structure of water. Now, this oxygen and this hydrogen have electronegativity difference. Now, because it is more electronegative, it will be -1, it will be +1 over here. Now, here also it is more electronegative, it will be -1, it will be +1 here. Now, oxygen has 2 -1 on it. That is why -1 will become -2. That is the reason oxygen has -2 oxidation number in this case. Right? Okay. Now, if they talk about why, what they are telling you about in this case, that with fluorine it has +1 or +2, what do you mean by that? It means that if you have let's say F2O, right? Or you can say FOF2, right? Or if you have O2F2, right? O2F2. Now what will happen? The structure is same. This is oxygen, this is fluorine, this is fluorine. Here also it is oxygen, oxygen, this is fluorine, this is fluorine. Now again the difference is in the electronegativities. Now we know that fluorine is more electronegative. That is why it will have -1, this will have +1. In this bond also it will have -1, this will have +1. That is the reason oxygen will have +2 charge here, right? Oxygen will have +2 oxidation state. But in this case, it will have +1, it will have -1, -1, it is +1. Now each oxygen has a +1 oxidation number. That is why in peroxide it is +1. This is what they have mentioned in this particular box, right? Okay. Now next is hydrogen's oxidation number is, most of its compound is +1. Because hydrogens are usually electropositive in nature in front of others. But in some cases, unless it is combined with a metal, like if hydrogen is combined like this NaH, now in front of a metal, right? Metal are electropositive in nature. In these cases, they will not act as proton, they will act as hydride ion. It will be -1, it will be +1 over here. right? That is why usually over hydrogen you have +1, but when it is combined with the metal, it has -1, right? Next is in compound the elements of group number 1, group number 2, group number 3. So if you talk about group number 1, because it can lose 1 electron, it is +1. Group number 2, it can lose 2 electrons, so it will be +2. And next is aluminium, that has +3 charge over it, right? Next is the sum of oxidation number of all the atoms in the neutral compound is 0. That's why whenever we are calculating the oxidation number for anything, let's say they are asking you to calculate it for, let's say, KMnO4. How do you calculate it? Very, very simple, right? This is the base of chemistry. How do we calculate it? We say that we want to find for Mn. This is potassium. Potassium belongs to group number 1. It is +1, right? Plus this is X. I am assuming it to be X, right? Minus, or you can say plus 4 multiplied by oxygen. Usually have -2 unless and until it's a peroxide bond. So it will be -2 equals to 0. So it will be X minus 8 plus 1 equals to 0. That means the overall charge I am taking as 0, right? Or overall, if it has this kind of charge, let's say if they have mentioned as KMnO4, K2M, let's say they have given you KMnO4 negative, or they have given you something else, Cr2O7 2 negative. Now the overall answer will be equals to the charge over it, right? Okay, that's how you calculate the oxidation state, okay, in a compound. Right? Okay. So these are the little things, right? Okay. These are the little things that help you in solving the oxidation numbers, right? Next is the sum of oxidation. The sum of oxidation number of all atoms in a polyatomic ion is equals to the charge on it. As I told you that if you talk about H2PO4 negative, it will be equals to -1. That is the charge over it. Okay. Got it? Yes, everybody. Simple. Now I'm going to show you some very, very important diagrams, right, where they can ask you the oxidation state, because in these kind of diagrams, in these kind of structures, they are different. Okay, that's why I have picked up these structures, right? So if you talk about, firstly, there is C3O2. Okay, C3O2. This is the structure of C3O2, right? Carbon has double bond, then again double bond. It has double bond with the oxygen as well. Now, what you have to think that each carbon will have different oxidation number. That is the reason we calculate a thing called fractional oxidation number. When each of the carbon has different oxidation states, some has 0, some has +2, then we calculate fractional. That means the average oxidation state that they will possess. Right? Now, ma'am, for individual, if I want to calculate for individual carbon, how to calculate the oxidation number? Right, so very simple way we will do that. Now, we know that this carbon, right, this carbon, now always remember, double bond means 2, triple bond means 3, single bond means 1, okay? Single bond means 1, double bond means 2, triple bond means 3. Just remember this thing, right? Now, we know that carbon is electropositive as compared to oxygen, so it will have +2 because of this double bond, and this will have -2 because of this double bond, right? If you talk about these two carbons, they are also bonded to each other, but there is no electronegativity difference here. That's why for these two, I'll put +0 here, right? Here also it will be +0. No effect, right? What about this particular carbon, carbon number 3? We know that this bond, again, this is more electronegative, it will be -2. This is less electronegative because of double bond, it will be +2. Now, if they ask you, if they mark a star over there, what is the oxidation state of this C2? Then oxidation state of this C2 is going to be 0. But overall oxidation state, if you want to say that overall charge is +4, that means +2 here and +2 here. On the carbon, overall charge is +4 and it is divided into 3 carbons. So it will be +4 by 3. That is why the fractional oxidation number is +4 by 3. Got it? Right? Now, next is this very beautiful butterfly structure of CrO5. Right? Okay. This is also a very important structure. Now, here again, what we will do. Okay, chalo. I'll just, if you want me to teach like this, why I'm teaching you like this, so that we can do it in a fast manner, right? Now this chromium you have, now understand students one thing, chromium is forming double bond with this oxygen over here. That is why for this oxygen here it is -2 because oxygen is more electronegative, and for chromium here I have written +2 here, right? Because it is a double bond. Now, when chromium is forming single bond with the oxygen, then what we are writing? Here it is -1, here it is +1, right? Now, with this particular bond, it is -1, it is +1. With this bond also, it is -1, it is +1. With this bond also, it is -1, +1. Now, chromium has +2, +1, +1, +1, +1. That becomes 6, right? That becomes 2, 3, 4, 5, 6. That means the oxidation state on chromium is going to be +6 here, right? Okay, what about this one? Here, this oxygen number 1 has -2, oxygen number 2, 3, 4, 5 have -1 charge, right? Okay, yes, Carose acid, very good, very good. That is called Carose acid, very good. Chalo, acha, what about this one? What about this one? Shabash beta, Carose acid. Huh. Now tell me beta, now tell me about this one. Now, this is the structure, right? Now, what exactly you need to see? Same thing, that this sulfur over here, it is forming a double bond here. It is -2, it is +2. That's why +2 I have written here. Over here also it is -2, +2. I have written +2 here. With this particular bond, it is +1 and -1 because it is a single bond, and oxygen is more electronegative in nature as compared to sulfur. Again, here it will be +1, -1. So overall, you will add these things in +2, +2, +1, +1. That means total it will be +6 on the sulfur atom. Now talking about the oxygens here, this particular oxygen will have which charge? Now this oxygen with this sulfur is electronegative, so it is -1 over here. Now this oxygen with this hydrogen also is electronegative in nature, so there will be one more -1 here. So in this oxygen there will be -2 charge overall, right? Okay, what about this oxygen here? In this oxygen you have, because of this sulfur is +1, this is -1, right? But when you talk about this oxygen and this oxygen, they don't have electronegativity difference here. That is why, because of this single bond, there will be no charge on the oxygen. That is why I will add +0 here. Right here also I will add +0. That is why this oxygen will have only -1 charge. Moreover, it is a peroxide bond, right? Okay. Now with this oxygen again, this oxygen with this oxygen and this oxygen number 3 and 2, they are forming a single bond, no electronegativity difference. So there will be no charge that will be because of this oxygen here. But because of this hydrogen here, it is +1, it is -1. Right? Now with this oxygen number 4 and 5, because of double bond, they have -2. Because of double bond, they have -2. Got it, everybody? Everybody got it? How you can answer these different things, right? Now again, a very interesting question on your screen, right? Okay, so this is Br3, 3, 4, 5, 6, 7, 8, O8, right? Br3O8, Br3O8, right? Now, how do you answer this? Same way, we know that bromine as compared to oxygen, right? Oxygen is more electronegative as compared to bromine, right? Now, that is why here double bond, it is -2, double bond, it is -2, double bond, it is -2. Double bond, it is +2, double bond, it is +2, double bond, it is +2. It is single bond, but no electronegativity difference. So, there will be no charge because of this bond. Hence, on bromine number 1, there is +6 charge. Hence, on bromine number 1, it is +6 charge. Now, what about this case? Double bond, it is -2, double bond, it is +2. Double bond, -2, double bond, +2, right? 2 + 2 will be added here. With this particular bromine, there is no electronegativity difference here. So, there is no charge because of this. Hence, on bromine number 2, the answer will be +4. Right? Over here, with the same case of this bromine, these are similar. So, bromine 3 will also be +3, right? +6. Now, the overall charge is +6, +6, +4. That is +16. Overall charge is +16. It is divided among 3 bromine atoms. So, it will be divided by 3. Hence, the fractional oxidation number is going to be +16/3. Okay, got it? Now, guys, I think we have revised one thing, that is oxidation number, oxidation state, fractional oxidation number. If that is clear to you, thank you beta. If that is clear to you, then let me know in the comment section so that we can start with the balancing part now, right? Balancing, we have two main methods. One is half reaction method, other is oxidation number method. So now let us see, with you can apply any method you find easy, right? Because in the exam they will, it's not a subjective exam, right? It's an objective exam. So if you find this easy, you can just learn this method. If you find that method easy, you can find that. Sometimes in the exam they can specify that this step of oxidation number method you tell, right? Then for that cause, I think you should know both the method, but you should also specify it in your head that which is easy for you, so that in the exam you don't get confused at which method you want to apply, right? Okay, so now let us firstly learn. The first method is half reaction method. So I'll give you very simple steps already given in your NCERT. There is no need to complex things because of some tricks, right? Okay, so just use what NCERT has already given you, right? So first method is half reaction method. Here we will divide that into two reactions. One is oxidation half, other is reduction half. So method is identify atoms undergoing oxidation and reduction. First you have to identify that which atom is going oxidation, which is under reduction. Separate two half cells, then you have to separate this among two half cells. Balance all atoms except hydrogen and oxygen. Firstly, don't balance hydrogen and oxygen. That is the last thing that you will do. Next is balance oxygen by adding H2O. Now, till here oxidation number and reduction are almost similar. Now this is the main part. Here what we are doing, balance all atoms except for hydrogen and oxygen, right? After that, balance oxygen by adding water, hydrogen by adding H positive, right? Now balancing of charge by adding electrons. If basic medium, add same amount of OH negative on both sides. These are the steps. Now, you can't learn the steps. You need to have example that, ma'am, what will happen, right? Because from balancing, definitely they will ask you question. Definitely. It's a very, very interesting question for redox reactions, right? So now let us see with the help of example. They have given us some random reaction, right? Okay. Try that should be in the ionic form, right? Okay. Try to make it in the ionic form. They have given you this reaction. First thing is, you need to calculate the oxidation number of each of the species. We know that Fe here is +2. Chromium, how you will calculate this will be 2x minus 8 is equals to, not 8, it will be 7, right? 7 to 14 is equals to -2. 2x is equals to 12, x is equals to 6. So, chromium is +6. Very, very important, some very, very important steps I'll tell you, right? This chromium is +6, right? Next is chromium +3. Here iron is +3, right? Okay. Now, we firstly have to identify atoms undergoing oxidation and reduction. So, oxidation and reduction, as you can see, oxidation number, just remember one thing, that in oxidation number is increasing. In reduction, oxidation number is decreasing. A simple way to identify that, right? So now as you can see, it is +2 to +3. That means oxidation number is increasing. It is +6 to +3. Oxidation number is decreasing. So that means this is the reduction, this is the oxidation. Now I'll divide it into two half cells, right? So I have divided it into two half cells here, right? Now main part will start here. Just remember, just don't see this page. See what I am telling you to see. Right? Okay. First thing is, firstly, you will balance all the atoms except for oxygen and hydrogen. Right? So, firstly, you will write only this thing, that is Fe2 positive give rise to Fe3 positive. That's it. No electron balancing we have done. This is one, it is balanced. Okay. What about this one? Here also we will firstly balance it. This is Cr2O7 negative. Here it was earlier only chromium 3 positive, right? Here it was Cr2O7 negative, it was chromium 3 positive. So that means chromium is the one that I need to balance. That is why I will multiply this by 2. Now I have also done the third step here, that is balance all the atoms except for hydrogen and oxygen. I have also balanced all the atoms here. Now next step is, wait a minute, next step was to balance the water by adding, balance the oxygen by adding water. Just remember one thing, in half reaction method, firstly you balance oxygen, then hydrogen, then you balance the charge, right? But in oxidation number method, charge balancing is done before balancing oxygen and hydrogen. That is the main difference that you have, right? Okay, so here firstly I will balance the oxygen atoms by adding water. Here I don't have any oxygen atoms, so I will not add any water here. In this case, I have 7 oxygen atom. That is why I will add how many water here? How many water I will add? For 7, I need to add 7 H2O, right? Okay, that's why I added 7, because in 7 H2 only you have 7 oxygen, right? Okay, so I'll add 7 oxygen on the opposite side to balance the oxygen. Now, ma'am, the next problem is hydrogen. Now, ma'am, here you have 14 hydrogen. Ma'am, here you have how many? No hydrogen present here. That's why I will balance the hydrogen by adding the H positive charge here, right? So I have added 14 H positive because here I had 14 hydrogens. Okay, understood? Now the main problem is charge balancing. Till here everything is simple. Okay, everything is simple here. Now what I'll do, I'll balance the charge here. How I will balance the charge? Now always remember, number of electrons gained should be equals to number of electron lost. Lost is on the oxidation side, gained is on the reduction side, right? Okay, so this is the reduction side. Here the electron will be gained. Now let us just erase this thing, erase this thing, erase this thing, right? Okay, I'll just tell you why I did that, right? Okay, so I'll erase it by this method only. I'll just erase it, erase this thing, right? So I'll just explain you that how we did the charge balancing, right? How we did the charge balancing, because that is the most important part here, right? Now, as you can see here, the charge will be, the charge that you will have here is a -2 charge over here and +14. +14 -2 is equals to +12 charge, right? Okay, that is +12 charge. Here what I have, here what I have, here what I have, this is Fe2 positive, this is +3. That means here 1 electron I need to lose here. 1 electron we will need to lose here. In this case, what I need to do, here you have 12 charge. So that means to make the charges equal, if here you have +12, so here you should have 12 electrons, right? Only then they will cancel each other and the charge will be equals to 0, right? Okay, if here you have, here what charge you have? Wait a minute. Here what charge you have? Here you have +12, right? Here what charge you have? +6. Okay, that means the difference is here you have +12, right? Okay, just give me, I don't have space to write here. Okay, so this is +14 -2, that is +12 charge on the left side. On the right side, you have 2 into 3, that is +6 charge. That means to make it equal, you need to add 6 electrons here. Only then 12 minus 6 will be equals to 6. Only then charge will be balanced. That is the reason here I will add 6 electrons. Okay, that is the reason we added 6 electrons here. Firstly, tell me, is this particular thing clear to everybody or not? Why I added 6 electrons here? That is the important part, right? Why I did that? Because here the charge was 7, this was -2, this is 14, the charge was 14 minus 2, it is equals to 16, right? Here charge is 3 into 2 plus 16, I am saying this is equals to 12, this is +6. So to make it equal, I need to subtract -6 from here. -6 means I need to add 6 electrons here, right? So that is why I'll add 6 electrons here. Here I have added 6 electrons. Here I have just, here I have lost only 1 electron. That means I have to multiply this by 6. That's why this was multiplied by 6. Okay. That's why this was multiplied by 6 to make the electrons and charge equal. Right. Okay. Now everything we have done. Next is just add these two equations and you will get your answer. This is equation number 1. This is equation number 2. Add these two equations. Right, you will get your answer. Now, very, very important part regarding the acidic and basic medium. If you have acidic medium, you should be fine with H positive. You look, okay, H positive, we have learned that. Okay, cool, right? But if they have given you basic medium, if they have given OH negative in the equation, that means they are talking about basic medium here. In the basic medium, Here you have 14H positive. You will add 14OH negative here. You will add 14OH negative here. This will become equals to 14 water, right? And this water you will subtract here. 7 will come to this side. This will become 7 water, and OH negative you have already added, that is 14. That is the difference, small difference between acidic and basic medium that you will do in the end, right? Okay, don't worry. After that, I'll also solve some previous year questions for you, right? So that you're able to answer that in the exam as well. Okay, yes, the method is clear in your head. Chalo, very good. Next is oxidation number method. A very small difference you will feel here. Not exactly very small, it's just that the steps are quite similar to each other, right? If you ask me, I would say a half reaction method, I find it easy as compared to oxidation number method, right? Rest is totally your choice, right? Okay, now here let us see what we have to do. Here let us see what we have to do. Oxidation number method. Identify atoms undergoing oxidation and reduction. First, you need to identify same procedure. Firstly, identify atoms undergoing oxidation reduction. After that, balance all atoms undergoing oxidation and reduction except for hydrogen and oxygen. Right? Okay. Next is find the change in the oxidation state and then cross multiply to balance the charge. Here I am telling you, firstly balance all the other atoms, then balance the charge. There what I told you, firstly balance the atoms, then balance oxygen, then balance hydrogen, then balance charge. Here balancing the charge is before balancing oxygen and hydrogen. That is the main important point that should be in your head, right? So before going to the rest of the points, I'll just show you till here what we are doing, right? Okay, what is this cross multiplication and all, right? So simply this is the equation that you have, some random, it's a very simple thing, okay? Some random equation they have given you. You know how to calculate the oxidation number. Simply calculate +4 -1, this is +1, this is -1, this is x minus 2, x minus 2 equals to 0, so x will be +2. Here elementary state it is 0, right? Okay, oxidation number. Can I say one thing here? Ma'am, why this is chlorine, this is also chlorine? Why you have not taken this point? Arey, because here chlorine is -1, here also chlorine is -1. I need to see that particular situation where oxidation number is changing. Here it is -1, here it is 0. So right, from -1 to 0, oxidation number is increasing. This is a oxidation number is increasing. Here it is +4 to +2, oxidation number is decreasing, right? Oxidation number is decreasing in this particular change. Now, next point is, okay ma'am, it is decreasing. Now, what is next? Next, I told you, balance all the atoms undergoing oxidation and reduction. Okay, manganese is 1, manganese is 1. Chlorine, you can say oxygen is 2. Oxygen, I can't see here. Oxygen, I don't care about oxygen. All I care is, except for oxygen and hydrogen, I have to balance all the atoms. Manganese is 1, manganese is 1. Chlorine here is 1. Chlorine here is 2 plus 2, that is 4. Right? That means I need to balance the chlorine. Right? So I'll balance the chlorine by multiplying it with 4. I don't care about hydrogen. Right? Okay. So I need to balance chlorine. Now, third step also done. Now, what is this charge balancing? Let's learn that. Okay, charge balancing is the most crucial step here. Rest of the steps are similar to the previous method, right? This is a very different method. This is a very different step as compared to before. What is this step? Firstly, we know that here it is +4, right? Here it is -1. Here it is +2. Here it is 0, right? I'll cross multiply the difference here. That means if I talk about this particular situation, in this case, what is happening? In this case, over here you have, wait a minute, -1, -2. Wait a minute, it should be -1. Wait a minute, guys. Why I've written minus 1 into 4 I have to write now. Acha, okay. Okay. I'll just tell you what is the difference, why this example is very important. See, here you have 2 chlorine atoms, here you have 1 chlorine atom, right? So you have to talk about 2 chlorine atoms only, right? That is the most important point here, that why I have picked minus 2 here, because here you have 2 chlorine atoms, right? Here you had 1 chlorine atom, so this will be multiplied by 2. So here 2 Cl negative is getting into Cl2, right? So answer will be minus 2 to 0 it is going. You don't need to multiply it by this 4, you need to multiply it by that number of chlorine atoms that you are talking about. So I'm talking about 2 chlorine atoms, it will be minus 2, minus 1 multiplied by minus 2, minus 2, this is 0, mod will be equals to 2, okay? Mod will be equals to 2. Here, over here also you have 1, over here also you have 1 manganese only. So it will be 4 minus 2, difference is 2. 2 will cancel each other. Firstly, though, you have to make it in the simple whole number ratio. This is 2, they will cancel each other. Now nothing will happen because 1 will be multiplied by this case, other will be multiplied. Here you have 1, here also you have 1 is the remaining thing. This 1 will be multiplied by these two things. This 1 will be multiplied by these two things, right? And hence this will be the answer, MnO2 plus 4HCl plus MnCl2 plus Cl2, right? Now to balance the oxygen, I'll have to add the water, right? So this is 2 oxygen, so I added 2 water and that will become the final answer here, right? Okay. I'll give you one more example on this, right? So that you will be able to understand this in more depth, right? Okay. Understood? Chalo. Now, let's see what I have done, because this particular step is slightly confusing. In the first method, there was no this kind of step, right? So there was no less chances of mistake in that particular reaction, that particular method. Here the chance of mistake is more. Though if you know this method, you will be able to solve this in within seconds, right? Okay. Chalo. This is a reaction that they have given you. Now understand, first thing that I'll do is to calculate the oxidation number. This is plus 6. Now why this is plus 6? This is 2x minus, wait a minute, this is plus 2 plus 2x minus 14 is equals to 0. 2x is equals to 12, x is equals to 6, right? So here can I say this is plus 6? Yes, I have written it. So chlorine here is minus 1. Here chlorine is also minus 1. This is plus 1. Here chlorine is plus 3 and here it is 0, right? Okay. Now, what I will do next? Now, next part is to just differentiate this thing here, that which is oxidation, which is reduction. This is plus 6, this is plus 3. Here I am talking about one single chromium atom. What I am talking about, one single chromium atom. So this is going to be the reduction, oxidation part. Wait a minute. This is plus 6 to plus 3. This is going to be the reduction part. And this is minus 1 to 0. This oxidation number is increasing. This is the oxidation part, right? Next is the balancing of the atom except for oxygen and hydrogen. I know that here you have 2 chromium. Here you have only 1 chromium. So that's why this will be multiplied by 2. Chlorine atoms, if we talk about chlorine, potassium, here it is 2. So this will also be multiplied by 2. This will also be multiplied by 2. Chlorine, if you talk about chlorine, here it is 1, right? Only 1. And here it is only 1. And here it is, this will be 2 plus this is 6 plus it is 2. So it is going to be, wait, I think I am also getting confused here. I need to rewrite it and then solve it. Hai na? Otherwise, I'll also get confused. Chalo, I'll just solve it in front of you only. K2Cr2. K2Cr2O7 plus it is HCl plus it is HCl give rise to this is KCl plus CrCl3 plus it is Cl2. Okay, chalo, let's do this and solve this together. If you talk about the oxidation number, let's write it plus 6, it was minus 1, it is plus 3, it is 0, right? So I can say that this particular part is my oxidation, sorry, reduction, this is oxidation, right? This is oxidation, this is reduction, right? Now they are asking me to balance all the atoms here, right? This is chromium 2. So here also I'll write it 2 chromium, right? Okay. So now if you talk about this thing here, it is going to be how many atoms here? Chromium is 2, chromium is this, chlorine is what? Chlorine, if you talk about chlorine is what? Chlorine is 1 here. Chlorine is how many? Chlorine is 3 to 6 plus 7, 8 plus 2, that will be 8, right? And here how many chlorine you have? You have only this much chlorine. So I think I should do one more thing here, because this potassium is 2, I'll just multiply it by 2 because I have to balance all the atoms here. This is multiplied by 2. Now how many chlorine you have? Here you have 1 chlorine. Here you have 2 plus 3 to 6 plus 2, that is 6, 7, 8, 9, 10 chlorine you have, right? 10 chlorine you have. So I'll just multiply this with 10, right? So I'll just multiply this with 10, right? Have I balanced all the atoms? Chlorine is 2, 6 plus 7, 8, 9, 10. And here also you have 10 chlorine. Chromium also I have balanced. Potassium also I have balanced. Now I have balanced all the atoms here, right? Next part was what? Next part was, once you have balanced the atoms, now you need to see what is the difference here, right? So difference how I will see? Difference how I will see? Everybody, let's see that here you are talking about 2 chromium, then here also talk about 2 chromium, right? So here if you talk about the chromium, here for 1 chromium the oxidation state is plus 6. For 2 chromium the oxidation state will be plus 12. So here it will be 12, over here it will be 12. Here for 1 chromium the oxidation state is plus 3. For 2 chromium the oxidation state is going to be plus 6. So it will be minus 6. Take the mod here. Take the mod of this one here. Take the mod of this thing here. This is 12. Take the mod. It will be 6. Right? Okay. Done. Understood this part? Acha. Next is chlorine. Now here, if I talk about this, this is 2 chlorine I am talking about. So for 1 chlorine, it is minus 1. For 2 chlorine, it will be minus 2. So let's say it is minus 2. Right? For 1 chlorine, it is 0. For 2 chlorine also, it will be 0. So answer will be minus 2. So answer will be in mod, it is 2. But till here, tell me, is that clear to every one of you or not, what we have done here? Right? Okay, students, everybody, let me know in the comment section if till here you understood the balancing, right? How I did the balancing. I just followed the steps here because these two things are the most crucial part, understanding that what difference I have taken. है ना? Ma'am, this was plus 6, ma'am, this was plus 3, you have taken it as 6, ma'am, how you took it? Right? Because 2 chromium I am talking about. So here also I'll talk about 2 chromium. Here I am talking about 2 chlorine. So I'll talk about only 2 chlorine. Right? Some students say, ma'am, minus 10, minus 0, it should be 10 here. Right? Okay. So that you should know. Acha, after that what I did, I'll just solve it into simple whole number ratio. This will be 1. This will be 3. Now students, I'll mention it by red pen. This 3 will be multiplied by the other factor here. So it will be multiplied here. It will be multiplied here. Right? This is 3 multiply. Here also 3 multiply. Acha. This 1 will be multiplied over here. Right? So this is 1. This is 1. Right? Okay. Multiply by 1. Okay. So answer that you will get is just add these two things. It will be K2Cr2O7 plus 30 HCl give rise to 2Cl plus 2. Wait a minute. This is 3 only, na? Two KCl. Wait a minute. 2 KCl plus it is 2 KCl plus 2 CrCl3. Let us see if is this balanced or not. 3 to 6 plus 3 to 6, right? Plus it is 2. So 6 to 12, 13, 14. 14 Cl over here I have. Why this is so? Why this is so? Let me see if there any mistake that we have done before. Wait a minute. This was HCl because it is not balanced. That's what I am looking into. If I only balance, if I don't balance the potassium, then it will be. If I don't balance the potassium, the problem is with this HCl. Na? Everything else is right. Problem is with this HCl. If I don't balance it, just give me a second. If I don't balance the Cl here, if I don't balance the potassium here, then it will be 2 potassium, right? If I don't balance it here, it will be 2 over here. It will be 1 HCl. If I don't balance it here, if I don't balance it here, it will be KCl, right? This will be 2 and this is 3. This will be, earlier it is 2, 3 to 6 plus 1, right? If I don't take this only. I'm sorry. This is what I'm thinking, that why it is not getting balanced. If I don't balance this thing, just give me a second. If I just copy paste this thing, just give me a second, guys. I'll just do one thing here to make it right. If I don't balance this particular thing, right? Okay. So I'll just plus this is KCl and this is okay. Chalo, just give me a second. I'll just balance all the atoms here. So this is 3Cl. This is 3Cl. When I balance it, it will be 2. It will be 3 to 6. Right? Okay. This will be 6Cl plus this will be 2 plus this will be 1. 6, 7, 8, 6, 7, 8, 9. 9Cl that you have. If you put it here potassium, it will be 1Cl. I need to change the potassium or what? Then everything else will be changed. Arey yaar. If I don't balance potassium only. Let's not balance potassium, then I'll see if we get the answer, if we get the balanced equation or not. If I don't balance the potassium, then it will be 3 to 6 Cl plus 2, that is 8. If I take it out of the equation only. If I take this out of the equation, then this is 8, right? Okay. So then this is 8, 3, 2, 6, 7, 8. Then this will be 8. 8 multiplied by 3 is 24. Oops, a very small mistake we have done here. I'll just rewrite it. Okay, I got it. What's the mistake that we did? Right? Okay, I'll just explain it again. Okay. Relax. Okay, I'll just explain it again. A very small mistake we have done. Everything else is right only. It's just one thing, one step I need to tell you here. That K2Cr2 plus HCl give rise to KCl plus CrCl3 plus Cl2. A very small mistake, right? Okay. So this is plus 6, this is plus 3, this is minus 1, this is minus 1 and this is 0, right? You need to balance only those equations, only those atoms which are under that particular process. Like for example, chlorine here, right, and chlorine here, chlorine here and here, right? Okay, so if you talk about this thing here, chromium is 2, so it will be 2, right? In these two processes, chromium is 3 to 6, right? Okay, and there it is 1 chromium here, right? Arey yaar, this is not oxidation. Beta, here we will not. I feel that sometimes if I do some blunder here, you start like, ma'am, this is wrong, ma'am, that is wrong. Beta, the steps are absolutely right only. Either this equation is wrong or no. Why this is 6 here? This will be 6 in no matter we are getting it 6. 3 to 6. Only then it is coming out to be 6. Chalo. Let's firstly balance through this particular method, right? Okay. So this is 0 and this is 1 Cl. So I'll just multiply it by 2, right? Okay. Understood how I am doing it right now? This is multiplied by 2. This is multiplied by 2. So I'm going to balance this again, right? Okay. Everybody look into this particular equation, right? Firstly, we write the oxidation numbers here. Then from this particular situation only, that this is 2 chromium and here you have 1 chromium, this will be multiplied by 2. Here you have 1 chlorine, here you have 2 chlorine, so this will be multiplied by 2, right? After that, don't balance any other thing, okay? Don't balance any other thing here. This is plus 6, this is plus 6. Now, we know that here oxidation, here reduction is occurring. Here oxidation we have. This will be equals to mod of, this is 6 into 12. This is 6, so that will be, everything is same only. Everything else is same only. This is minus 2 and for 1 chlorine it is minus 1. For 2 chlorine it is minus 2. Minus 2 to 0, it will be equals to 2 only, right? Now what we will do, this is equals to 1, this is equals to 2. Now we will multiply this by 2. 2 will be multiplied here. Achha, this will be 3, right? So 3 will be multiplied here, right? And 3 is going to multiply over here, right? Then 1 we will multiply here and 1 we will multiply here, okay? 1 we will multiply here. Now next is what you will get is K2Cr2O7 plus 6HCl, right? Give rise to KCl plus CrCl, 2CrCl3 plus 3Cl2, right? This is what you will get, right? Now you need to balance the oxygen and hydrogens here, right? Okay, now you need to balance the oxygens and hydrogens here. If you talk about this thing is your balanced equation. Now if I want to balance the chlorines here, chlorine is here is equals to, chlorine here is equals to, chlorine here is equals to 6. Here it is how many chlorine? Here potassium is 2. So now I will multiply it by 2. Now you can see chlorine is 6 chlorine here. Now how many chlorine you have? 2 plus 3 into 6 plus 3 to 6. Right? So it will be 12, 13, 14. 14 chlorine you have here. Right? Okay. So you have to make this 6 into 14. Is this 14 only? 3 to 6, 3 to 6, 6, 6, 12, 13, 14. 14 chlorine you need to make it. So it will be equals to, how can I make 6 into 14? I don't know why we are not getting it right. Acha, we'll just again just make it 14, right? Okay, just erase this and make it 14, right? If I make it 14 now, because hydrogen I can arrange. Hydrogen, this is 14 H positive and this is no H positive. So if I add H positive here, now what I need to balance? Now I need to balance the oxygen here, right? Chalo. Oxygen, if I balance, this is 17. So firstly, I'll balance the oxygen part here. Oxygen is 7. So that means I need to add 7 water here. Now 7 water means you have 14 H here, 14 H here, 7 oxygen here, 7 oxygen here. This is the balanced equation that you will have. Okay, one just little mistake what we did is, we balanced this chlorine firstly, right? We balance this chlorine firstly. This chlorine will not be balanced. That is not under the equation. Rather, otherwise what will happen now? This thing will happen in this case, because now you have 30 HCl, right? If you want to balance this thing here only, you can balance it here, right? How you can balance this thing here, right? If you solved it like this, it's not like it's an incorrect method. If you solve it here also, it is coming to be something different only, right? Now, if you balanced it before only, this is what you will get. Now, what you will see that this is 30 Cl and this is what again? 3 to 6, 6 plus 6, 14 HCl. So, again you have to erase this and you have to make it 14 HCl. Then again you will do the same thing, that is, this is 7 H positive. So, 7 water will be added, right? And 14 H you have, right? So basically what I want to tell you that you can also balance it with this particular method, but I think that got little bit confusing to me as well, right? Because once you see 30 HCl, it will be difficult for you to handle the other Cls. But if you solve by this method, that is, you don't solve, you just balance the equations, balance the atoms that are there in the reduction or oxidation half cell. Like here I am talking about chromium, I only balance the chromium atom here. Here I am talking about Cl, I only balance the Cl atom firstly. Then even I got something very different, but here I can erase this and get it solved the same manner. Here also I can get it solved the same manner, but here the problem is that if you have 14 HCl here, right? Okay, here you just need to erase it. If you had 30 HCl here, you need to erase it and make it, because you can always balance the H positive easily. So this will be 14 HCl after that. Got it? Yes. Okay. Chalo. Oh, that was a weird funny thing, right? Okay. Chalo. Understood, guys? Okay. How you need to balance this particular thing, it's totally your choice how you want to balance it. You can balance it before also, you can balance it after also. I'll just explain it one more time, right, for my own satisfaction, because I think some students got confused here. Okay, chalo. By oxidation number method, how do you balance this? Firstly, you just see this particular equation, right? Then you have K2Cr2O7, right? You have HCl, you have Cl, KCl, Cr, Cl3 and Cl2. Firstly, you need to mention the oxidation numbers. Then you need to see that how many chromium you have. You have 2 chromium, here it should be 2 chromium. Here you have 1 HCl, here should also be 1 HCl, right? In this particular situation, you should have 2 Cl, here also it should be 2 Cl. So I multiplied it by 2. Now I'll calculate the difference here. This is for 2, it is plus 12, and for 2 it is plus 6. So answer will be 6. Here it is, for 1 it is 2, so with 2 it is minus 2. With 1 it is 0, with 2 it is 0. So answer will be 2. They will be cancelled, it will be 3, it will be 1. So 3 is multiplied here and 1 is multiplied on the opposite side. After that, you will get something 6 HCl here. Then HCl you need to delete and you need to make it 12, because over here you will have 14 HCl. So you need to make it also 14, because hydrogen can be balanced afterwards with the help of H positive. But you don't need to add H positive here, because you have 7 water and you can add 7 water here by balancing it. Right? Okay? Yes. Chalo. Now, next is the titrations part. Right? Titration part, just remember one thing, right? It's a little bit cramming part, right? Just remember there is Anita, right? Anita is a analyte, right? Anita is a female which is unknown, right? Okay, female is unknown means girls are very complicated, na? So female is unknown. Now, Anita is a female, F for flask, right? Now, this is the flask. When you do the titrations, you need to understand one thing. In the flask, you have analyte. Analyte is always unknown to you. And in the burette, right? In the burette, you have the titrant, right? In the burette, you have the titrant that is always known to you. How to remember this? Anita is a female which is unknown. Tarun is a boy which is known, right? TBK, right? Okay, so with that you can understand the basic nature of this titrations, right? Now for titration, N1V1 is equals to N2V2, always we do this. We calculate the normality or molarity of the unknown solution with the help of the known solution, right? Next is indicators. Now indicators, guys, you have self indicators and you have internal indicators. There are external indicators also, but they are not in your syllabus. So self indicator, starch or iodide, right? What they do when they oxidize, they give deep blue color. In the reduction, they are colorless, right? If you talk about internal indicators, KMNO4 itself is an internal indicator. It gives off pink color. It has its own color is pink color. But this give indicator with the starch. Okay, iodine give indication with the starch. It needs the help of the starch. Now we have back titrations. What are back titrations? See, back titrations are same with this one. It says that here you have one extra member, right? Okay, here you have one extra member. Who don't know Baswa sir, right? So that's why I'll be writing here, because NEET aspirants know Baswa sir. He'll be writing out boy. Okay, so there is Anita and there is Tarun, right? And there is one boy, right? Okay, so what exactly happened? Anita is a very clever person, Tarun is a very innocent person. So instead of boy, we can write here, instead of boy, we can write one thing here, that is going to be any sir, right? B, you can write B is someone who is checking on you, right? So you can write it Banita. Okay, Banita, right? So there is Anita and there is Tarun and there is Banita. So Banita bought some chocolates for you, right? Okay, so now what will happen here? When Banita bought some chocolates for you, she gave those chocolates to he gave those she you can take it as she gave those chocolates to Anita. Now Anita was very clever. She was like, okay, she has given me 20 chocolates, so I'll eat some 15 chocolates out of that. She ate 15 chocolates from her, right? Now Anita didn't told Banita how many chocolates she ate. And Banita was asking that how many chocolates you ate, how many chocolates you ate, right? She was like, I won't tell you how many chocolates I ate. Now Tarun is an innocent person, right? So Banita thought that with the help of this Tarun is titrant. Titrant is always known to you. Anita is unknown to you, right? Okay. So Tarun is known to you, right? So that's why with the help of this innocent Tarun, right? If Tarun said that I have eaten only 5 chocolates, because there were only 5 chocolates that were remaining. So now out of 20, if you have 5 chocolates remaining, you can easily tell 15 chocolates Anita has ate, right? In the same manner, back titration happens here, right? You have this titrating mixture where you have, first you have Anita and you have Tarun. You are adding what here? You are adding B here, right? So firstly, Anita will eat that chocolate, right? Anita will eat, Anita will eat, Anita will eat, Anita will eat, Anita will eat. Rest of the thing, titrant will eat. Now, titrant concentration is known to you. With the help of titrant, you will be able to answer this, that total number of chocolates is equal to how many Anita ate plus how many Tarun ate, right? So that means total concentration of this B will be equals to what analyte has taken out and what titrant has taken, right? From there you can calculate the equivalent weight of the analyte is equals to this B, that is the full mixture that is given to you, right, minus of the titrant, right? E means equivalent weight that we are talking about, right? Okay, chal. Next is iodometric and Iodometric. Now this is also a simple thing only. Iodometric, O means oxidized. So I negative is firstly oxidized here, right? Here directly I2 is reduced, right? Just remember this. This means O. O means I negative is oxidized first. Iodometry, directly I2 will be reduced. In this case also I2 will be reduced, but firstly I negative will be oxidized here, right? So two-step process it is, indirect it is. Firstly, I negative with the help of an oxidizing agent, it will be oxidized to I2. After that, this reduction will happen where it will be converted back to I negative and it will give that colorless color. It will be colorless after that. I2 in the presence of starch is giving us a blue color. But in this case, what will happen? One step direct reaction it is. I2 is reduced here. Simple manner directly. You have I2 which is blue in color, right? With the help with starch, I2 gives blue color. So after the reducing agent with S2O3O negative, it will give you I negative, which is a colorless solution. That means both are same. The difference is here first step is missing. Here you have one step, here you have two step, where I negative is oxidized firstly, right? So it's an indirect titration. This is a direct titration, right? Okay, understood. So that's a process here, that firstly you have I negative that is oxidized to I2, right, in the presence of an oxidizing agent, right? Here what you will have, I2 in the help with the help of hypo solution, which is acting as a reducing agent, that is acting as a reducing agent, that will reduce it, right, to I negative again, and this will be colorless, right? Blue color will disappear here, right? Okay, understood. Chalo. Now next is two formulas that you have, three formulas in fact that you have, right? Derivation you don't need to know, just simple direct formulas. Remember, volume strength of H2O2 is equals to 11.2 into molarity or 5.6 into normality, right? Okay, because H2O2 N factor is 2, that's the reason, right? Okay, strength of H2A2, if they ask you, just multiply 34 multiplied by molarity. Molarity will be given to you in the question, or if normality is given, you can calculate the molarity from there. If they ask you percentage weight by volume, that is equals to strength that you have calculated here divided by 10, right? That is going to be percentage weight by volume, right? Okay. Now, if they ask you what is Y percentage of oleum sample, oleum sample is basically you have H2SO4 and SO3, it will form oleum, right? So they are asking you the Y percent of oleum sample. They will be asking the percentage of free SO3. This is asked, okay? So directly they will just give you some question, some hint they will give you in the question, and they will ask you percentage of free SO3, that will be equals to 80 by 18. Y is what the sample will be given to you. For example, they give you 109% of oleum sample. Oleum sample. Now 109% means you will put the value y is equals to 109. So that will be 80 by 18 multiplied by 109 minus 100%. That is going to be the answer there, right? So what you need to do here is you need to just put the value of y here and you will get your answer, right? So for example, 108% is given to you, put the value it as 108 minus 100, that is 8, right? Okay, so by this method you can easily calculate the answer. Okay, students? Yes, everybody. Now I'll be picking out some questions of redox reactions in front of you, right? Let me just see where we started redox reactions. Okay, I think this was the redox reaction. And this is not redox reaction. This is also not redox reaction. Let me see where we started redox reactions. Okay, I think from here we should start redox reactions. Okay, chalo. Everybody, let us solve some questions of redox reactions. Okay, right? Everybody, let us start some questions of redox reactions. Right, everybody? I can't see that in the comment section. Yes, students. Wait a minute, let me just pick the questions of redox reactions. Mixed questions you have basically, na? Acha, do you want to firstly revise electrochemistry? Because I think I don't have separate questions here. I have mixed questions of redox plus electrochemistry. So I think better we do firstly, let's revise electrochemistry, okay? Because there are mixed questions, right? Okay, chalo. Now, let us revise electrochemistry after that. Electrochemistry is basically you have two things here. One is electrochemical cell, other is electrolytic cell. In electrochemical cell, chemical energy is converted to electrical. In electrolytic cell, electrical energy is converted to chemical energy. Right? Here what you will see, just remember one thing for electrochemical cell, that is LOAN. L is loss of electron, O is oxidation, A is anode, N is the negative electrode. Right? Now, here that means anode is the negative electron. But in electrolytic cell, things will be opposite. In this case, anode will be the positive electrode that you will have. In this case, anode is the negative electrode that you have. Okay, so the major difference about electrolytic and electrochemical cell is here anode is negative, here anode is positive. Here you have chemical to electrical energy, here it is electrical to chemical energy. Firstly, we will talk about electrochemical cell, then we will study about electrolytic cell as well. Right? Okay. Now, next is electrochemical cell. If you talk about the electrochemical cell, that is equals to electrochemical cell is Daniell cell. Okay, the most famous cell is the Daniell cell. So, Daniell cell specified for zinc and copper, when you have zinc and copper, right? And that too, if you talk about zinc and copper here, if zinc and copper is at 1 molar concentration, that case, that Daniell cell is named as galvanic or voltaic cell. So that is the difference between Daniell galvanic and voltaic cell. Right? Now this is a full diagram, right? We will see that what exactly happens here. So if you talk about this case, we know that at anode there is loss of electron, right? So zinc is present at anode. This is the oxidation half cell where zinc is present. So this zinc electrode that you can see here, zinc electrode here, what is happening in this case? This zinc electrode is losing the electron and getting converted into ions here. So that means some of it will lose the electron and get converted into ions, because from here one atom, it will lose the electron, get converted into ions. So what will happen? The thickness of the anode will decrease here, right? And the electrons that you have, those electrons will travel to this particular position, right? They will travel. That is why M meter will show the current deviation here, right? Electrons will flow from zinc to copper. That's why electrons are flowing from zinc to copper. From zinc to copper, electrons will flow here. And what you will see, at cathode side, there is gain of electrons. So at cathode, copper 2 positive will gain the electron and will be converted to copper. That means in this case, what will happen? That means in this electrode, what will happen? Earlier, it was like this. Now, because some of the ions are gaining the electron, that way what will happen? The thickness of this cathode will increase because some ions are gaining the electron and getting converted to copper. So that means thickness of the cathode will increase here, right? Now, the flow of electron and current are always opposite because electrons are flowing on this direction, current will be in the opposite direction. So current is from copper to zinc, that is in the opposite direction, right? Next thing is, now what is this salt bridge that you have drawn here? This is a salt bridge that I have drawn here. Salt bridge is a U-shaped bridge. What is the reason that we have drawn this salt bridge? What is the need of salt bridge? As I am telling you that on the oxidation half cell, that is on the anode side, we have more cations. That means in this solution, you will have positive charge. Positive charge will increase in this solution. And here what is happening? You have CuSO4, that means you have Cu positive and SO4 2 negative. Cu2 positive are getting eliminated because Cu2 positive are getting converted into copper. And here thickness is increasing. That means in this solution, you have negativity. you have negative ions of SO4 2 negative that will be left behind. That means the electrical neutrality of the system will get disturbed. This is positive, this is negative solution. That is the reason we need a neutral electrolytes to balance these things. And in the salt bridge, we have those kind of electrolytes. For example, let's talk about, you have KNO2, right? So here K positive and NO2 negative, these are the two electrolytes that you will have here. To this solution, to the anode side, an anion will jump here so that this positive will be balanced by a negative ion here from the salt bridge, right? And to this side where you have negative charge, in this what will happen, a positive charge from the electrolyte will join and it will maintain the electrical neutrality of these two solutions. So that is why we are saying that it is a U-shaped tube where anionic, that means the anion part is moved to anode side, the cation part is moved to the cathode side, right? Now, next thing is, what is the condition of choosing the electrolyte here? Now, the condition is the mobility of cation and anion should be same, right? So, that's why there are only few electrolytes that we choose here. It's not all the electrolytes that we choose here, right? Okay. Next is, why agar-agar solution we put here? Because we want the mobility to be not to be that much that suddenly so many ions we add here. It should be very slow process. That is why a thick paste is added here. Moreover, in this at this particular point, you have glass wool also to slow down the speed of the electrolytes, right? So that was about the Daniell cell. Now, next question that they can ask you is, next question that they can ask you is based on the external potential that you add. Now, when you talk about the external potential here, if external potential is less than 1.5, 1.1 is the external potential of the Daniell cell. If the external potential is less than that, then nothing will happen. For example, someone wants to disturb you, right? If external potential is less, like they don't have that much power, so they will not be able to disturb you. If their power is like equal to your power, then you will stop studying, right? Just like I can see some of the students in the comment section have stopped studying, right? If their external potential is greater than 1.1, that means they have overpowered you, then things will get reversed. That means earlier the electrons were going from zinc to copper, but now in this particular case, electrons will move from copper to zinc and the current will move from zinc to copper. Okay, understood? Next is standard electrode potential. What is this standard electrode potential? This is when you talk about concentration is 1 molar, for gases it is 1 atmospheric temperature is 298 Kelvin. Right, it is represented by E naught cell, and a standard formula you have, that is E naught cell is equals to E naught, the one that is at cathode, reduction potential of that particular atom element, right, minus of E naught at anode, the one electrode that is at anode, the reaction that is happening at anode, and the reduction potential of that reaction. So it is E naught cathode minus E naught anode, but both should be reduction potentials. Okay. Now, if you talk about the representation of the cell, so it is E to EX positive, right? This is this represents salt bridge that we have mentioned by U-tube, not YouTube, it is U-tube. Okay, so this is A to X positive. As you can see, just remember AC, right? We use AC in our home, na? So A is anode side, C is the A is the anode side, C is the apna cathode side. Okay, so it will always be A, then you have C, right? So firstly you will write the anode side, then you will write the cathode side here. Anode side means loss of electron, cathode side means gain of electron. This is how the reactions in the redox reaction will be balanced, will be mentioned. Now another important point is the relationship from where also the questions are asked, right? So reduction potential means when you are gaining the electron, how much potential you need, right? Okay, so that is the reduction potential. More the reduction potential, more will be the oxidizing power, less will be the oxidation potential and less will be the reduction power, right? Okay, reducing power. So just remember this thing, okay? More is the oxidation potential, more is the oxidizing power, less is the oxidation potential, less is the oxidizing power, right? Okay, next is some formulas here, right? Most the formulas that you will use are mentioned here only. First formula is the relation between delta G and E naught cell, that is delta G is equals to minus NF E naught cell. Second is delta G naught is equals to minus 2.303 RT log base 10 Kc between equilibrium constant and delta G naught. Now combining these two things, we have a new formula, that is E naught cell is equals to 0.059 divided by N log Kc. That has been generated from the Nernst equation, as you can see here, right? Okay, so Nernst equation is basically E cell, right, not at standard condition. E cell is equals to E naught cell minus of 2.303 RT by NF. Now, when you calculate the value of 2.303 RT by F, that comes out to be 0.059, right? Okay, so directly you can learn this formula. E cell is equals to E naught cell minus 0.059 by N log oxidation by reduction, right? Okay, the one which is under oxidation divided by the one which is under reduction. In some books you will see they have written it as QC, right? So when at equilibrium, we know that at equilibrium E cell is equals to 0. Because E cell is equals to 0 at equilibrium, that's why, wait a minute, just need to erase this thing. Sure. Okay, so E cell is equals to 0 at equilibrium, that's why E naught cell will be equals to 0.059 divided by N log of oxidation by reduction, that is at equilibrium QC will become equals to Kc. So we have written Kc here. Okay, got it? Chalo. Next thing is spontaneous, non-spontaneous reaction. Now we know that in spontaneous reaction, delta G is less than 0, right? If delta G is less than 0, so this negative will be positive. So E naught cell will be greater than 0. If you put E naught cell is greater than 0, so Kc will be greater than 1, because if this term is positive, then this term, this particular Kc should be greater than 1, right? So that's why we have written here that Kc is greater than 1. For non-spontaneous, delta G should be positive, so E naught cell is negative and Kc is less than 1. Okay. Now there is one question that they can ask you based on the conversion here, right? Conversion, right? So conversion, you can say conservation, not conversion, it should be written conservation. Conservation of energy. Now if you talk about the conservation, let's say you have a reaction where A is getting converted to A positive. A positive is getting converted to A2 positive, right? Let's say I'm talking that here you have E1 naught is the electrode potential. Here E2 naught is the electrode potential. Here you have E3 naught is the electrode potential. Here it is N1 number of electrons you are gaining, losing. Here N2 number of electrons you are losing. Here N3 number of electrons you are losing. Because I need to make a general formula for you here, right? In this case, if they ask you the value of, let's say they are asking you what is the value of E3 naught. Let's say they are asking the value of E2 naught. Then remember, electrode potential is not additive in nature, but Gibbs free energy is additive in nature. So delta G naught of 3, that means this full circle will be equals to delta G of 1 and delta G of 2. Then you put the value of delta G, that is equals to minus NF E naught cell. If you put this thing, this is minus NF, this is minus NF, this is also minus NF. These things will be cancelled out and you will have the answer as N3 E naught 3 is equals to N1 E naught 1 plus N2 E naught 2. Now, whatever they ask you, they can ask you the value of E3, they can ask you the value of E2, E1. Whatever they ask you, you can directly answer with the help of this particular formula. Okay, got it? Right, everybody? Students, is that clear? Next is the resistance here, right? For resistance, you need to firstly know what is metallic and electrical conductivity. So metallic conductivity is basically the flow. In the metal, you have kernels, you have metal atom, and electrons are, flowing here. So it is due to the flow of electrons. But electrolytic conductivity is due to the flow of ions in the solution, right? Here you have no chemical reaction, electrons are flowing, right? Here you have chemical reaction, because of that ions are getting formed and ions are flowing, right? Here no transfer of matter as such, electrons are getting here and there. Here you have the transfer of matter because ions are moving here. Ions possess some matter, they have some mass, right? Electrons don't have mass, right? They have negligible mass. Effect of temperature is a very, very important point, that in metallic conductivity, when you increase the temperature, conductivity decreases here. But in this case, when you increase the temperature, conductivity increases here, right? Here it is decreases because it is due to the flow of electrons, right? And in the metallic structure, the kernels are very near to each other. What will happen? When you increase the temperature, the vibrations will increase. They will hinder the path of electron. But in this case, as you increase the temperature, ions will have more path to move, right? So that's why conductivity increases in the electrolytic solution. Okay. Next, let us talk about the resistance, right? Resistance, guys, that is mentioned by R. Conductance is G. Resistivity is rho, that is like a snake, right? Conductivity is K, that is called kappa, right? These are the units, simple, right? Now, you must have seen this formula in this physics also. R is equals to rho L by A, where we know that L by A is mentioned as cell constant, that is mentioned as G star. So now questions are asked from this particular formula, that is G star is equals to K, that is conductance multiplied by cell constant is equals to conductivity, right? That's a very, very important formula, right? Okay, next is usually, right, this formula is of use, right? But still you should remember this formula also. Usually this formula is of use, right? Usually this formula is not of use, but still, because JEE mains, so you need to know both the formulas. What if they give some random question, simple question, it's just the game of the units. So if kappa, that is conductivity, is given in ohm per ohm meter, right? Then you can say the formula will be kappa divided by molarity into 1000, right? But if that is given in per ohm centimeter, in that case answer will be kappa into 1000 divided by molarity, and for equivalent conductivity it will be kappa into 1000 by normality, right? Okay. Now next is for dilution, right? Acha. For dilution, what you need to do, and this is now this we are calculating at C concentration, that is this molarity we are talking about. Now the direct relation, that if dilution increases, concentration decreases. More water you are adding, concentration is getting decreased in that solution, right? Because concentration is getting decreased in that solution, so conductivity will decrease, but molar conductivity will increase. It's a very, very important point, that conductivity of that solution, when you are diluting something, conductivity will decrease here, right? Because conductivity, if you know the definition of conductivity, conductivity means that you have a beaker, in that they are representing you some volume, right? They are giving you some volume. In that volume, they are asking you the conductivity. Conductance is throughout this particular cell, throughout this beaker, this concentration. But for conductivity, we are mentioning some unit volume here, right? So for that unit volume, if I take, this is the unit volume that you have, and earlier you had, let's say, these many ions. But now when you are adding the more water, so ions will decrease now, because water will take place of that in that particular. For example, let's say I have let's say I don't even have any box here, right? Okay, so bad, I don't have any box. Chalo, I have this thing. Let's say this is the unit volume that I am talking about. Earlier, let's say I have 3 ions here, right? Earlier, let's say I have 10 ions here. Now, when I'll add water into it in the same volume, ions will be less. That is the reason conductivity decreases. Then, ma'am, why molar conductivity having no effect? Because molar conductivity is not mentioning the volume. Molar conductivity means in 1 mole what will happen. And more often, you know that molar conductivity is inversely proportional to the concentration, that is molarity. If molarity decreases, right, we are saying that concentration decreases, then this will definitely increase. And that is the reason molar conductivity will increase here. Okay, that is the reason molar conductivity will increase here. Okay, chalo. Now, moving forward to Kohlrausch law. So, when you have strong electrolyte, then you have weak electrolyte. So, if we talk about a strong electrolyte, in that case, it will equals to molar conductivity at concentration C is equals to molar conductivity at 0, infinite concentration, infinite dilution, not concentration, minus AC half. If I draw a graph here, I can see that this is Y is equals to mx plus C. So the slope is negative, right? And intercept is nothing but here it is molar conductivity at infinite dilution. So that means for strong electrolyte, I can easily calculate the infinite dilution molar conductivity with the help of a graph. But in case of weak electrolyte, the molar conductivity at infinite dilution I can't calculate. Reason being, the graph is not having any intercept here. It is going parallel to the y-axis. That is the reason we have Kohlrausch law, which tells us the molar conductivity of the weak electrolyte. It says that molar conductivity of the weak electrolyte is equals to the molar conductivity of the individual ions here, right? If it is AB, it will be molar conductivity of A positive plus B positive. If it is AB2, it will be equals to molar conductivity of A2 positive plus 2 into B negative, right? Okay, like this, you will have the answer. Now, next is size is directly proportional. More is the size, they can ask you because this is directly given in your NCERT chart, right? That size is directly proportional to the infinite molar conductivity except for hydrogen. This is not applicable to hydrogen, right? So, more is the size. We know that sodium has more size as compared to lithium. That is the reason molar conductivity of sodium is more as compared to the lithium. That is infinite molar conductivity. Next is a simple equation that we have done in equilibrium as well. Weak electrolyte, so Ka will be equals to C alpha square, right? This we have done in ionic equilibrium as well. So that means Ka is equals to C alpha square, that we know. Now, how we can calculate the value of alpha? That is the degree of dissociation. So that is equals to molar conductivity at concentration C. This you will solve with the help of kappa into 1000 by molarity, right? And this you will understand with the help of Kohlrausch law, right? Okay, this is by formula, this is by Kohlrausch law. After that, you can calculate the value of degree of dissociation. Then you can calculate the value of dissociation constant as well, right? Okay, students. Last is electrolytic cell, right? Okay, then we will start with the question. Electrolytic cell, right, and product of electrolysis are two very, very important things, right? Okay. So, electrolytic cell, if you talk about, right, electrolytic cell is very, very simple, right? Electrolytic cell simply means that anode is positive here, right? Okay. And here, what will happen? You will give the electricity and some chemical reactions will occur in this case, right? Everything else is going to remain the same, right? So this is the process. Here what is happening, I'll just tell you what is happening in this case. You have CuSO4 solution you have, and here everything is in just one beaker. You have both the electrodes in one beaker only. You have one solution here and two electrodes you have. Okay, I'll just explain you one electrolytic cell. Rest of I'll give you the results of that, right? Now, what is going to happen here? This is the anode part. Anode, we know that loss of electrons will occur. So the impure electrode in the anode side, you will have impure electrode if you are doing the purification process. So impure electrode you will have, impure will dust off the impurities, and here you will have the anode mud, and copper is converted to copper 2 positive plus 2 electrons here. Right? Now copper 2 positive ions are there in this solution, they are there in this solution. At anode there will be gain of electrons, so copper 2 positive ions in the solution only, they will gain the electron and they will get stick to this particular electrode. So here what will happen, earlier this was the electrode and earlier this was the electrode, impure electrode. Now what will happen in this reaction, impure electrode will lose the ions, and here anode mud will be formed. Copper 2 positive ions that were lost here, they will accept the electron and get converted into pure electrode. So in this case what will happen, again thickness will increase on the cathode side, and this is what you will have in the end, and hence all the full impure electrode will be converted into the pure electrode. That is called purification, right? Okay. Acha, next is, wait a minute, next is the selectivity principle. Now guys, exactly what happens now in let's say NaCl, let's talk about NaCl aqueous, right? You have NaCl aqueous. We know that NaCl aqueous means you have Na positive, Cl negative, aqueous means you have H positive, OH negative. Now the problem is which will win here? Which on cathode what will be formed, on anode what will be formed? This is the question that they ask you, right? So simple way, right? I'm just firstly giving you the full procedure here, what is happening here, what will happen, what they can ask you individually. First thing is selectivity. So at cathode that will be selected which has more maximum reduction potential. Now at cathode means over here, at cathode there will be gain of electrons, that means here, right? Now it should have maximum reduction potential. If sodium Na positive has more reduction potential, that will be selected. If H positive has more reduction potential, that will be selected. Now what we do here, we take here also water, we take here also water. Water under reduction shows this kind of process where it generates H2 and its reduction potential is minus 0.83, right? This can be directly asked to you. And water under oxidation generates O2 and its oxidation potential is taken as minus 1.23 only, but exactly it is minus 1.43, but it is taken as 1.23 only, right? Okay. Now, next is at anode which will be selected, which has more oxidation potential, that will be selected. So that is the cause that how we select the which reaction will occur at cathode and anode, right? Okay, that is how we select it. Now inert electrodes are those which will not participate. If nothing is mentioned to you, that means they are taking inert electrode. If they have mentioned that this is the active, they have mentioned some like here we know that copper is that electrode which is participating here. So here you don't have inert electrode, right? Okay, so either you will have active electrode that will participate in the solution. Now which are here I have given you all the answers, right? Because see, it's very difficult to learn the electrode potential, it's not possible. Like let's be practical, right? So in the exam you will not be able to solve everything, but this you can remember definitely. Instead of remembering the electrode potential, this you can remember, right? Okay. So for NaCl aqueous, anode is chlorine, cathode is H2, right? Okay. Anode is yes. For Na2SO4, cathode is H2, anode is O2, right? For H2SO4, cathode is H2, anode is O2, right? For CuSO4, cathode is Cu, anode is O2. But for CuSO4 in copper electrode, anode is also copper, anode is copper 2 positive, cathode is copper. This we have done in purification process, right? Anode is copper 2 positive, cathode is copper, right? This we have done in purification process. For AgNO3 aqueous, cathode is Ag, anode is O2, right? Here AgNO3 aqueous plus Ag, again cathode is Ag, anode is Ag positive. I think with this thing, already you know that in this is purification, this is purification, right? At purification, at cathode, there will be thickness will increase. At anode, it will be converted into ions, right? Simply that will be done. If you talk about Na2SO4 and H2SO4, same answer you have. At cathode, you have H2, and at anode, you have O2, right? This is also done. Now, CuSO4 and AgNO3, aqueous, aqueous. Here at cathode, you have that metal, that you Cu, and here you have Ag. At anode, in both the cases, you have O2, right? This is also done. And NaCl is a very, very famous thing. That is, at anode, you have Cl2, at cathode, you have H2. Now, guys, tell me, is that clear to everybody or not? Right? Directly, you can, I think now, only when you have this kind of chart in front of you, right, it's not difficult to learn things, right? But remembering electrode potential of each of the following at this point 10 days before the exam, that is tough, right? Okay, got it? Yes, thank you beta. Is that clear? Board beta, it will be too much, right, frankly, but still, yes, you can watch this. Acha students, shall we start with the questions now? Everybody. Okay, everybody in the comment section. Shall we start with the questions? Wait a minute. Let me just change my mic. Okay. Okay. Am I audible now? Am I audible? I'm audible, guys. Everybody. Shall we start? Everybody in the comment section. Chal. Yes, ma'am. Yes, ma'am. So I'll do it in a very fast manner now. Right? Okay. Chal. Now the question here is what pressure of H2 would be required to make EMF of the hydrogen electrode in pure water at 25 degrees Celsius, right? So now they are saying what pressure of H2 would be required, right? To make EMF of the hydrogen electrode zero in the pure water. They have given you pure water here. So what you will do, now we know that if you're talking about if you're talking about the reaction here, this is basically H positive is getting converted to, they're basically talking about SHE only, right? H positive is getting converted into H2 here, right? So now what will just apply the Nernst equation? We know that on the product side you have the pressure, you have gas, that's why you will apply, instead of concentration you will write pressure here, so it is pressure of H2. On the reactant side you have H positive, so this will be H positive raised to power 2, right? Products by reactants, right? Okay, so I'll be products by reactants. Now H positive concentration is not given to you, but they are telling you that this is pure water. So for pure water, H positive concentration is 10 raised to power minus 7. OH negative concentration is also 10 raised to power minus 7, right? So talking about the H positive concentration, that will be 2, right? 10 raised to power minus 7, right? So raised to power 2, because you have 2 H positive ions here, right? Then it is, everything is right. So this E naught cell, we know that SHE is equals to 0, right? For standard hydrogen potential, right? It is 0, right? And E is also 0 for that, because it is a pure water, right? So it is 0, it is 0. Now from here we can say that this is 0, so this goes to this side, this will also be equals to 0. That means log of pH2 by 10 raised to power minus 14 is equals to 0. You take it here, it will be, this log will be equals to 0. So when you have log of something equals to 0, that means the term here is equals to 1, right? Okay, that means pressure of H2 by 10 raised to power minus 14 is equals to 1. That means pressure of H2 will be equals to 10 raised to power minus 14 bar. So answer will be equals to D is the correct answer here. Okay, next question is, now they are saying that one of the commonly used One of the commonly used electrode is calomel electrode. Under which of the following categories calomel electrode comes? Is it under, guys, this we have not studied this in the theory part today. Reason being because that is an entirely theory based thing, right? You can study it from your NCRT last 2-3 pages they are, right? Okay. Are nahi bhai, it is not recorded. Yes, everybody. So, one of the commonly used electrode, calomel electrode, under which of the following category this follows? Oxidation reduction, metal ion, metal electrode, gas ion electrode, metal insoluble salt, ion electrode. Yes, which of the following is it? It is under? It is under which of the following? Metal insoluble anion electrode, right? Metal insoluble anion electrode it is. Yes, students. Okay, this is a theory, direct conceptual based question. Okay. Acha, next is for strong electrolyte, a plot of molar conductivity. This is a numerical based question. Molar conductivity against concentration under root is a straight line which with a negative slope, the correct unit for the slope. This bit I have just told you, strong electrolyte, we have seen that graph also, right? Everybody. Everybody. What was the graph that we have shown? I've just showed you one page now where we have shown that y is equals to mx plus c. Y is equals to mx plus c. We have done that now. Y is equals to mx plus c. Right? From there, this was the slope. I'll just tell you just one simple thing here. Basically, this is the thing that we saw. Right? Now, this is a equation of straight line for the strong electrolyte. We know that when something is under addition or subtraction, the units will be same. Right? That means the units of this molar conductivity at infinite dilution and the units of this are going to be same. Molar conductivity has the units is equals to Siemens centimeter square per mole. That are the units. That means the units of A multiplied by under root C is going to be the same. Right? Now, if I divide it by under root C, that is if I divide it by per mole this, if I divide it by per mole minus 2, okay, because this is, wait a minute, this is under root C, concentration is what? This will be per square mole, right? This will be under root C. Under root C is concentration. Concentration means it will be mole per liter. Under root C means it will be 1 by 2, right? Okay, so it will come there and it will be mole per liter minus 1 by 2, right? Okay, solve this thing. It will be S centimeter square, right? Liter will be L 1 by 2 because this will become multiplied by minus 1. It will become plus half, right? This M will be equals to minus, again it will be minus 1. This is mole minus half. Minus 1 minus half is equals to minus 3 by 2. So here answer will be minus 3 by 2. Okay. So S centimeter square L half mole minus 3 by 2. So that is going to be the answer, right? That we can see the answer will be equals to B, right? Okay. So very simple question it was. Next is for fuel cell. So again, it is a theory based question that they are saying fuel cell using hydrogen and oxygen as fuels has been used. Again, this is has been used in spaceship, has efficiency of 40%, uses aluminium as catalyst, is eco-friendly, is actually a type of galvanic cell only. Which of the following is the correct answer here? Everybody, which of the following is the correct answer here? Has been used in a spaceship. Fuel cell, you have H2, you have O2, right? Okay, so fuel cell has been used in a spaceship. Yes, we use it in the astronaut use it. That's why they are able to breathe, right? So has an efficiency of 40% to produce electricity, right? It's a wrong thing, right? Okay, it does not have efficiency of 40, it has more efficiency. Uses aluminium as a catalyst, right? Aluminium is not used as catalyst here, right? Okay, now is eco-friendly. Definitely it is eco-friendly in nature, that's why it is very famous, right? Okay, it's very eco-friendly, means it does not disturb the environment. Is actually a type of galvanic cell only. Yes, it is a type of galvanic cell only, just like Daniel cell, like it's a electrochemical cell, right? So answer is A, D and E. A, D and E, that means B will become the correct answer here, right? Okay, B will become the correct answer here. Next question guys, on your screen we have molar ionic conductivities of divalent cation. Acha, molar ionic conductivity of divalent cation and anions are this and this. Molar ionic conductivity is given to you. Molar conductivity of solution of an electrolyte with the above cation and anion is. Molar conductivity of a solution of electrolyte. It's a very, very simple question, guys. Try to answer this. Very, very simple question. A very, very simple question. Everybody. Divalent cation and anion you have, if I take it as A positive. Now, I want you guys to answer this, right? It's a very, very simple question, right? What we do here, just apply Kohlrausch law here. You have divalent cation, divalent anion. Conductivities, molar conductivities are given to you. They're asking you for that particular solution, what is the conductivity. So we know that according to Kohlrausch law, it is sum of the individual ions. So that will be cationic plus anionic, that is 130 is going to be the correct answer, right? Okay, chalo. Next is, how can an electrochemical cell be converted into an electrolytic cell? Electrochemical cell to electrolytic cell. That I have told you, external potential you have to apply. Now, how we can reverse it? How we can reverse it, everybody? Very, very simple, right? Very, very simple, guys. Very, very simple, everybody. How we can reverse the external, how we can reverse the electrochemical cell, right? How we can reverse it? Applying an external potential opposite potential, external potential, opposite potential lower than E naught cell, reversing the flow of ions, applying an external opposite potential greater than E naught cell, exchanging the electrodes at anode and cathode. So we have to apply the external potential which is greater, right? So answer will be C is the correct answer, right? Okay. Next question is the EMF of the cell. Next is EMF of the cell that is given to you, right? Cell is given to you. Cu2 positive, this is Cu, this is 0.01 and this is 0.001. I think this is a question of Nernst equation, is it? Kind of. EMF of the cell, they are saying how it is increased. Firstly, let's draw the reaction here. Let's write the reaction. It is Ti is getting converted to Ti positive. Cu2 positive is getting converted to Cu. That means here you have gain of 2 electrons. Gain of 2 electrons, right? Here you have Ti positive. That means you will lose 2 electrons. So that means Ti positive, 1 electron is lost, because here 2 electrons are gained, so it will be multiplied by 2. Now, if you want to write out this reaction, we know that this is the loss of electrons. So this is the anode side, this is the cathode side, right? So here E will be E naught cell minus 0.059 log of, by N is 2, right? Because N factor number of electron exchange is 2, right? Log of oxidation by reduction. Oxidation is happening here. So this is Ti 2, because 2 ions you have, right? Divided by Cu2 positive, right? Now they are saying what you can do here, decreasing the concentration of both this and this. If you decrease both the concentration here, Then what will happen here? What will happen? You decrease the concentration of TL, and this is TL, no? Acha, this should be TL. Chalo, I'll just write TL. Okay. Now, when you decrease both the concentration, this whole amount, it will not affect the log, right? Then both should not be decreased now, because then we can't exactly say what will happen. It depends upon how much decrement you are doing, right? Okay, how much decrement you are doing, it depends on that. Increasing the concentration of Cu2 positive ion. If you increase the concentration of Cu2 positive, then this whole term, because if you increase this concentration, right? Okay, this concentration is increased, then this will decrease, right? Okay. If this concentration is increased, wait a minute, let me just teach you. This concentration is increased, that means this whole term will decrease, right? That means this term will decrease. That means from E0 cell, the amount that you are taking out is less now. That means the full, they are talking about this EMF. That means EMF will eventually increase here. So answer will be B. Rest is when you increase the concentration. When you increase this concentration, this term will increase, this term will increase, then this full term will decrease, right? Increasing the concentration of both this and this ion, that is same as this. Both we can't predict that what will happen, right? So answer will be B is the correct answer. Okay. Next question is the reaction that is given to you. Next question, guys. Everybody, next question is, reaction is given to you, occurs in which the following galvanic cell they have given you, they are asking you, the reaction is this one, occurs in which of the following galvanic cell? That means the representation they are asking you. Yes, students, the representation they are asking you. Everybody, representation, how you will do the representation? Firstly, though, we need to see what exactly is happening here. This is positive, this is negative. We know that if this is a salt bridge, right? Okay, then what should happen here? Which is converting to which thing? At anode, what is happening? At cathode, what is happening? This is Ag positive, this is Ag0. So Ag positive is getting converted to Ag0. That means oxidation state is increasing, right? That means anode reaction. In this case, this oxidation state is 0. Here it is +1. So this is from H2 to H positive, right? Okay. Now, this is at cathode side, right? Okay. Chalo. Now let us see. At anode, we will write it first, right? Okay. Then we will write the cathode one. Oxidation. Array, nahi, wait a minute. Here oxidation number is decreasing. This is +1 to 0. This is cathode. This is cathode. Right? This is from 0 to +1, it is increasing. This is the anode side. That means on the anode side, on the left side, you will write H2 and HCl. Right? That you will write here. H2 and HCl, that you will write here. We know that H2 is getting converted to HCl, not KCl. Right? So this is not the answer. This is also not the answer. H2 is getting converted to HCl. On the cathode side, Ag is getting converted to Ag. Right? You have AgCl to Ag. Right? Not AgNO3. So answer will be very simple. B is the correct answer. Okay? Very good. Chalo. Next is graph is given to you. Right? Graph is given to you. Molar conductivity for electrolyte A, B. Very good, students. Very good. Abhirami, Dhansika, Sanjay, Kritik. Very good, very good, very good. Right? Nahi beta, the answer will not be KCl. KCl is not there in the question only. How can answer be KCl? KCl is not there in the question. It should be given in the reaction, no? If we want to write the representation of that. Right? Okay? Ma'am, the answer for this question in 2024, instead of HCl, there is KCl. Huh. If in the question there is KCl, then the answer will be KCl, right? It depends on the question, the reaction that you have. Okay. Now, next question, guys. Everybody, now I want to know the answer for next question. Molar conductivity for electrolyte A and B are plotted against this as shown below. It's a very, very simple question here. Very, very simple. A is mentioning that which is parallel. Parallel, it is getting parallel. So that means it is for weak electrolyte, right? Okay, that is for weak electrolyte. Now, other one they are showing that intercept will occur here, right? So that means it is for strong electrolyte. So answer will be C is the correct answer, isn't it? Yes, students, C is going to be the correct answer. Okay, chalo. Next question is the standard reduction potential at 298 Kelvin for the following half cells are given below. I think here we will use that concept only. Chalo. The number of metals which will oxidize, wait a minute, the number of metals which will be oxidized by Cr2O7O negative in aqueous solution. Oxidized by, so this is the oxidizing agent, right? We need to see, this is the oxidizing agent, we need to see which is a good reducing agent, right? Okay, understood. For this one, for its oxidation, right? Here they have given you, this is from +6 to +3. Here they have given you the reduction, right? Okay, the reduction of this thing. The number of metals which will be oxidized by Cr2O72 negative. If this is a good oxidizing agent, so it itself will be get reduced, right? So it itself will get reduced, that means it will have the reduction potential, right? Its reduction potential is given to be 1.33, right? That is given to be 1.33, right? Okay. Now, remember one thing, if you want to see which metal will be oxidized, right? That means it should have a good oxidation potential. That metal should have a good oxidation potential to get oxidized, right? Here they have given you the reduction potential. So the oxidation potential will be 0.04. Here oxidation potential will be 0.25. Oxidation potential will be minus 0.80. Oxidation potential will be minus 1.4, right? That will be the oxidation potential. Reduction potential is 1.33, right? Okay. So which will have a good higher oxidation potential, that only will get. So even if we talk about the reduction potential, even in that case, even if we talk about the reduction potential, let's solve it through the method of reduction potential only. Here the reduction potential is 1.33, right? It will only oxidize those things which has lower reduction potential as compared to 1.33, right? We need to have low oxidation potential, low reduction potential. The one which has lower oxidation potential than this will be able to oxidize more easily, will be able to get themselves oxidized fast. So we need to have lower oxidation potential as compared to this. Again, I'm saying lower reduction potential, higher oxidation potential, right? Lower reduction potential, higher oxidation potential, right? So lower reduction potential as compared to 1.33, this is low, this is low, this is also low, this is 1.33, this is 1.4, this is not low. So answer will be Fe, Ni and Ag. So answer will be 3, that is Fe, Ni and Ag are going to be the correct answer, right? Okay, okay guys, everybody. Okay, we need to see the lower reduction potential, because lower reduction potential will have higher oxidation potential. If you want to solve it with the method of oxidation potential, then oxidation potential, this will be 1.33. Oxidation potential will be 0.04. oxidation potential 0.04, this is 0.25, this is minus 0.80, minus 1.40, right? So now you need to see the higher oxidation potential as compared to this one, which is this and this has higher, this has lower oxidation potential, right? So it depends on what you want to see. I solved it with the help of reduction potential, right? Okay, yes, where E naught is reduction. Ma'am, why don't we do E naught cathode, this positive, where E naught is reduction? You are asking me or you are telling me? We use the reduction potential only there. It depends on you. You can also use oxidation potential. Na? Actually, answer is E naught cell is equals to E naught of cathode has reduction potential, anode has oxidation potential. But we know that the oxidation potential of anode is minus of the reduction potential. That's why we put minus here and we use here reduction potential. So that always and always when you need to solve any question, you solve it by reduction potential. You don't need to convert things again and again, right? To make it easy for you, that formula is given to you, right? Okay. Chalo. Next question is, which out of the following is correct statement, correct equation to show change in molar conductivity with respect to concentration of weak electrolyte if the symbols carry their usual meaning? Yes, students, if the symbols carry here their usual meaning, which of the following will represent the correct equation of weak electrolyte? Weak electrolyte, guys, weak electrolyte. Following is correct equation to show change in the molar conductivity with respect to concentration for a weak electrolyte if the symbol carry their usual meaning, right? Okay. This is for strong electrolyte. This is the equation same as this, molar conductivity minus A. This is for strong electrolyte, right? Now, we know that if you want to know the answer here, right, then what you need to do, this also cannot be the correct answer, right? The question is between these two, right? Because that is so directly seen that direct equation will not be the correct answer here, right? So you need to solve it, right? You need to solve it with equilibrium constant, right? You need to solve this equation, right, to find out whether B or C is the correct answer. Let's solve it here. Let's take a simple any weak electrolyte we are taking, right? We know that weak electrolyte is equals to Ka is equals to this alpha square. This we have done before also. How? This is C, this is 0, this is 0. This is C minus C alpha. This is C alpha, this is C alpha. So Ka will be equals to C square alpha square. C common 1 minus alpha, this will cancel out, answer will be C alpha square 1 minus alpha. So directly they have written here alpha, C alpha square 1 minus alpha, right? Okay, now what you need to do, just solve this particular equation. This is 1 minus alpha, take it here alpha square, acha, this is alpha square C. Acha beta, are you able to understand this now? This will be equals to, wait a minute, I'll just write it here, Ka minus Ka alpha is equals to C alpha square, right? If you multiply this to this side, this will be the answer. Then you solve it in the form of any of this equation, right? So that will be alpha square C plus Ka alpha minus Ka. Alpha value also we know what is the value of alpha. Alpha is the molar conductivity at C concentration divided by molar conductivity at infinite dilution. Right, so just put the value of alpha here in these two cases and this is the equation that you will get here, right? This is the equation that you will get here because here this will be multiplied here. If you multiply this full thing with at infinite dilution square, then this will be cancelled, right? Here there will be one multiplication with infinite dilution and here will be infinite dilution square multiplication, right? Okay, after that what you need to do, just this equation related to the option here, option which will be, it will be second option is the closest here, right? Okay, so it was a very, very simple question. It's just a very simple derivation was needed. From this equation only for weak electrolyte, put the value of alpha in this and then just solve it, right? In maths, how you solve the equation, simple way, solve the equation there, right? Okay. Now, next question is match the following. Now, this is from batteries and cells, secondary, primary batteries. Okay, students, now let's study here. Acha. Leclanche cell, what kind of cell it is? Converts energy of combustion into electrical energy, does not involve any ion in solution and is used in hearing aids. Right, hearing aids. Okay, fuel cell is sorry. Reaction at anode is Zn to Zn2 positive 2 electrons. Okay. Nickel cadmium cell, fuel cell, mercury cell, it is given to you. Match the following things with the properties, right? If you talk about the fuel cell is fuel cell is helps, it is a very eco-friendly in nature, right? So fuel cell converts energy of combustion to electrical energy. That means C is 1. C is 1 only in one case, right? So everything is eliminated here. We are left with only one option here, right? Okay. Acha. Mercury cell. If you talk about the mercury cell, if you talk about the nickel cadmium cell, right? If you talk about this Leclanche cell, the reaction at anode is fourth reaction is this one. If you talk about nickel cadmium cell, definitely it is rechargeable, right? Okay. Then you talk about mercury cell, that is used in hearing aids, right? Hearing aids or which where we don't want that much electrical energy, right? So these are basically from primary and secondary batteries that I was telling you, that you have one or two pages of NCRT. You need to go through every single line of that NCRT: primary batteries, secondary batteries, right? Like Leclanche cell, nickel cadmium, the reactions, fuel cell, mercury, corrosion, right? Rusting. Simple equations are given to you. Very, very important. The application part is also very important there. In this way, they can ask you from the theory part, right? Okay. Chalo. Next question, guys, on your screen. Everybody, very good. D is the correct answer. Let's solve it here, everybody. Let's solve it here. I think this is similar to the first question that we did. This is similar to the first question that we did for electrochemistry. The potential for the given half cell is they are asking you. This is the equation that is given to you. H positive concentration is given to be. Now they are not talking about pure water. They were talking about pure water in the initial first question. That's why I took it as 10 to the power minus 7. Here it is given to be 1 molar. Pressure is given to be 2. They are asking you the Acha. E naught cell we already know. E naught cell is 0 here, right? Okay. So let's see. E is equals to E naught cell, Nernst equation only, minus 0.059 divided by N log is oxidation by reduction. Product by reactants, you can say product is this one, that is pressure of H2, right? Reactant is H positive raised to power 2, right? We know that the value of E naught is 0. So this will be E is equals to this one. How many electrons you are gaining or losing? That N factor is equals to 2. Pressure is given to be 2, right? And mole is 1 square. So that is 2 only. So your answer will be this. Log of 2 is also given to you. That is 0.3, right? So here that will become the answer. Okay? Yes, everybody? Okay. There will be minus here because E naught cell minus na, so it will be minus 0.059 divided by 2, 0.3, right? That is going to be the answer, right? Okay. Just solve this. By solving, what you will get, the answer will be equals to 0.9 into 10 raised to power minus 2, right? If you want to solve it, 0.9 is nothing but approximately equals to 1 only, right? Chalo. Next question is Consider the following redox reaction. Redox reaction is given is a very, very important question. Okay. In this, what they are saying that standard reduction potential are given to you. Equilibrium constant they are asking you. What is the relation between E naught cell and equilibrium constant? I want to see it in the comment section. Ma'am is given as, अरे बेटा, अच्छा, it is given as 0.06. चलो ठीक है. If it is given as 0.06, it is making it even easier for you, right? So you can, अरे that is same only ना. Approximately also you can take it as that, right? Okay. अच्छा. Next is this one here. Firstly, from Nernst equation, you will calculate the value of E cell, right? Okay. Then you will solve the value of equilibrium constant from there. Yes, students, everybody. Everybody, let me know. Acha, chalo, I'll give you one hint here. Okay, I'll give you one simple hint. What is the Nernst equation? Let's write it here. What is the value of Nernst equation? Nernst equation is E is equals to E naught cell. E cell is equals to E naught cell minus 0.059 divided by N log of QC. At equilibrium, we know that at equilibrium E naught cell is equals to 0, right? And E naught cell is equals to 0 at equilibrium, QC will become equals to KC. So this is the reaction. This is the formula that I told you, that E cell is equals to minus 0.59. Wait a minute. E cell is equals to minus. E cell is equals to, E cell will be 0. Now wait a minute. Why I have written that is equals to 0. So E naught cell, this is E cell, right? At equilibrium, E cell will be equals to 0. So this will be eliminated. It will come to this side. Answer will be this one. Now, they are asking you to calculate the value of equilibrium constant above reaction is given as K equilibrium 10 raised to power x. That means you just need to calculate the value of K equilibrium. Just calculate the value of log Kc here. Log Kc you need to calculate. For that, number of electrons and E naught cell you want to know. E naught cell, we know that is equals to E naught of cathode minus E naught of anode, right? Now firstly tell me which is cathode and which is anode. Which is cathode and which is anode here? If you talk about this thing here, this is x minus 8 is equals to minus 1, x is equals to plus 7. This is plus 7 and this is plus 2. Oxidation number is decreasing here. That means the reduction you can see. Reduction is occurring here, right? Okay, reduction means cathode side. That means here I need to see the reduction potential of this one. Here they have given you reduction potential only. Reduction potential is given to you because decrease in oxidation state they have given you here. So it will be 1.51 minus of what? Oxidation, where oxidation is occurring, as you can see, this is plus 2 plus 2x is equals to minus 8. Minus 8 is equals to 0. 2x is equals to 6. X is equals to plus 3. This is plus 3, right? Okay. This you can also say this is basically C2O42 negative, right? Oxalate this is, right? So it is 2x minus 8 is equals to minus 2. X is equals to 6 by 2, that is plus 3. And this is oxidation, C double bond O, C double bond O. It is plus 2, that is plus 4, right? Okay. So here it is, oxidation number is increasing. This is the oxidation part. Acha, now let us see this, whether they have given you oxidation or reduction. They have given you from CO2 to this. That means they have given you reduction potential only. You need to know that also, right? So this is minus of 0.49. It will be 1.51 plus 0.49. That is E naught cell. Put it here. N is equals to, what is the value of N here? Here what is happening? Plus 7 to plus 2. And here we have plus 3 to plus 4. Right? Plus 7 to plus 2 means 5 electrons it is gaining. Here it is gaining only 1 electron. So that will be multiplied by 5. This will be multiplied by 5 and 5 will be the answer. So n factor will be 5. N factor will be 5. Okay? Arey yaar. Okay? Okay, students? Everybody? Okay, students? Wait a minute. This is manganese. This is manganese. 1 electron it is gaining. Wait a minute. Here too we need to apply this redox reaction concept also. Right? Here you have 1 carbon. है ना? This is plus 7 2 plus 7 to plus 2. Right? 5 electrons it is gaining. Here for 1 carbon it is plus 3. For 2 carbon it is plus 6. Right? Okay. Here for 1 carbon it is plus 4. For 2 electrons, 2 carbons it will be plus 8. So 2 electrons you will have here. Right? 2 electrons you have. For 1 carbon you have plus 3. For 2 carbons you have plus 6. So this will be also multiplied by 2. This will be multiplied by 5. It will be 10 and 10 electrons. N factor is not 5. N factor is going to be 10 here. Right? Okay. Okay, N factor is going to be 10 because here I told you in apna balancing of the equations, right? That when you're calculating the oxidation number, also count this thing here. How many carbons you have, right? Okay. So here N factor is 10. Everything else you have E naught cell you also know. N factor you also know. Calculate the value of log C, right? Okay. So if you calculate the value of log, that will become equals to 33.8, right? So answer will be C. If log K is 33.8, then 10 raised to power 33.8, you can say 9. So answer will be 10 raised to power 339. Okay, so answer is going to be 339 is the correct answer because they are asking the value of X here, right? Okay. Okay, guys, understood? Everybody? Everybody understood or not? Everyone in the comment section? Everyone in the comment section, is that clear or not? Next question is, which of the following statement is correct about rusting of iron? Rusting of iron, coating of iron surface by tin prevents rusting even if tin coating is peeling off. Okay. When lies above 9 or 10, rusting of iron does not take place. Which lies above? pH or what they're asking you? Dissolved acidic oxides, I think pH only they are saying, iron does not take place, yes. Okay, so dissolved acidic oxide of SO2, NO2 in water act as catalyst in the process of rusting, that is true, right? Rusting of iron is envisaged as setting up of electrochemical cell on the surface of iron object. That means electrochemical reaction is occurring here in the rusting of reaction. Right? First statement is definitely incorrect. Coating of iron surface by tin prevents rusting even if tin coating is peeling off. So that is the incorrect statement. They are asking you not correct. So A will be the correct answer here. Right? Okay. Yes, everybody. Now let us see what they are saying. The reduction potential. Now they are saying the reduction potential of ions are given below. 3 ions are given to you. Correct order of oxidizing power. Very, very simple question this is. Reduction potential is inversely proportional to the more the reduction potential. Something wants to get reduced. I want to get reduced, right? So my reduction potential is more. I want to get reduced means I want to oxidize someone. That means my oxidizing power will be more. If I have a good reduction potential, my tendency to oxidize someone will be more. That means oxidizing power will be more, right? Okay, so just find out which has more reduction potential. Everybody find out which has maximum reduction potential. Maximum reduction potential, everybody, I have already given you the answer, right? Now you just need to arrange that properly, right? Okay, now you just need to arrange that properly, right? Okay, very good, right? So maximum reduction potential is of BrO4, then you have IO4, then you have ClO4. So answer will be BrO4, then you have IO4, then you have ClO4. So B is going to be the correct answer, right? Okay, chalo. Next is next the metals that are employed in the battery industry are, guys, the metals that are employed in the battery industries, right? Those batteries that we were talking about, right? In those batteries industries, oof, Fe, Mn, nickel, chromium and cadmium. Nickel cadmium cell we have seen, right? Manganese, lead is not given to us here. Iron in battery industries is not employed. Chromium also in battery industries is not employed, right? So these two things will not be employed, right? Okay, so B, C and E, right? B, C and E, that is A is the correct answer, right? Okay. I'll take practical chemistry. Don't worry. Next week I'm going to take up practical chemistry only. Okay. Next question is identify the factor from the following that does not affect electrolytic conductance of a solution. Electrolytic conductance, guys. Very good. A is the correct answer. Very good. Very good. Vinta, I will definitely take that. Don't worry about that. Yes, don't worry about that. Acha. Identify the factor from the following that does not affect the electrolytic conductance, right? Electrolytic conductance, the nature of the electrolyte added. Electrolytic conductance is dependent on the electrolyte added, like the amount of ions it will form, the tendency, the nature of the electrode used. That does not affect the electrolytic conductance of a solution. Okay, the nature of the electrode does not affect the electrolytic conductance now. So the nature of the electrode used, the concentration of the electrolyte will affect, the nature of the solvent will also affect. So which of the following will not affect? The nature of the electrode used will not affect the electrolytic conductance here, right? Okay, so answer is going to be B. Next is, this is from redox reactions. I think now we have started for redox reactions, right? This is basically, I haven't taught you this thing in today's lecture. Reason being because, this is only be taught in the, when you have some examples, right? Okay. So those who already know, let me know with the help of examples. So combination reaction is two reactants combining to give one single product, right? Okay. So this is basically an example of combination reaction. So this is A is 4. A is 4 only in one case. So answer is C is the correct answer, right? Okay. Still we will see the other parts also. This is PB, PBO. This is NO2 and O2. When one single thing is getting converted to different reactants, that means one single reactant is giving products here. That means it is decomposition reaction. So answer will be 1, decomposition. This is Na and water. This is basically your displacement reaction, metal displacement reaction. So C is second, that is the displacement reaction. When you have a metal that is getting displaced here, right? This Na was earlier alone, now it is with OH. Now this hydrogen is left alone. So this is displacement reaction. So this is a very, very simple concept, okay? So this is NO2 plus 2OH. This is basically, now out of this, disproportionation reaction is something you can learn, right? Because disproportion is something I can teach you. Everything else is like what we used to study in 9th class, right? Now here disproportionation is when one oxidation state, one atom that exists in one particular oxidation state, that atom is getting oxidized and reduced in that similar reaction, right? So if you talk about this thing here, NO2 here, so X minus 4 is equals to 0. Here nitrogen is in +4 oxidation state. If you talk about this nitrogen, x minus 4 is equals to -1, x is equals to +5. This is +5 and this is NO3 is x minus 6 minus 1. So x is equals to, this is +5, NO2. NO2 x3 to 6 minus 1, right? That will be equals to, wait a minute, this is x minus 4 is equals to -1. It is x is equals to +3, sorry. So this will be x minus 4 is equals to -1, x is equals to +3 oxidation state. This is x minus 6 is equals to -1. This is x is equals to +5 oxidation state. So +4 is also getting reduced, right, to +3. It is also getting oxidized to +5. So this is a disproportionation reaction, right? Okay. So answer is C is the correct answer, right? Okay. Huh. Very good. Next is among the following. Now they are giving you some. So they have given you some 1, 2, 3, 4 compounds, or you can say 4 elements, right? 4 monatomic things, diatomic elements, where they are saying what are undergoing disproportionation reaction. Disproportionation reaction means it should give lower oxidation state and higher oxidation state as well. Because fluorine, right, it has maximum electronegativity, right? So with -1 only is the oxidation state that it can exist. It can't decrease its oxidation state, or you can say it can't get, like, if something it has more, or for example, if I am the most powerful person, right, then I can't, after retiring, there is no other position that I can get. So fluorine is the most powerful person here. That's why it can't exist in other oxidation state, right? It can't increase its oxidation state. That is why it will not give the disproportionation reaction, right? So Cl2, Br2 and I2 will give the disproportionation reactions here, right? Okay. Yes. Now next is, see, from redox reactions, very simple questions are asked only. So this is from titration, right? If you remember this particular thing, thiosulfate reacts differently with iodine and bromine in the reaction given below, right? They are saying it is reacting differently. Which of the following statements justify the above dual behavior, right? Now, basically what they are saying, that you have S2O3 2 negative, S4O6 2 negative. Here S2O3 2 negative is getting converted to SO4 2 negative. Let's firstly write the oxidation states here. Adha to you will solve it with the help of oxidation states only. 2x minus 6 is equals to -2, -2, x 2x is equals to +4, x is equals to +2. So this is +2, this is +2, right? If you talk about this thing here, it will be 4x minus, this is 2x minus 6 only, -2 now, right? Okay, so this is 4x, right? This is 4x minus 12 is equals to -2, x 4x is equals to 10, x is equals to 10 by 4. So it's kind of fractional oxidation state that you can see here. This, if you remember this, I have shown you before also in the starting of the redox reaction. I have shown you some structure. This is among that only, right? Okay, so this is 5 by 2. You can say it is approximately 2.5, right? And this one is SO4. This is x minus 8 is equals to -2. So it will be equals to x is equals to +6 here, right? X is equals to +6. So what exactly they want to show you? If we take it as +2, just randomly take it as +2, fractional only we will take here, right? Okay, because we want to give a theoretical question here. They are not asking a numerical question to answer the each of the following sulfur, what is the oxidation number. We just need to draw a conclusion here that this is from +2 to +6. This is from +2 to +2.5. That means the sulfur oxidation, right, is happening. Oxidation number is increasing, but the increment is more in this case. So Four options you have. Bromine is stronger oxidant than iodine, right? Because here bromine is oxidizing, here iodine is oxidizing. Bromine is oxidizing to a greater extent. That means bromine is a stronger oxidizing agent. That is the true statement, right? Okay. If they're asking only one, then this is the true. Otherwise, let's see the other statements. Thiosulfate undergoes oxidation by bromine and reduction by iodine. This is absolutely incorrect. Bromine is weak. That is also not correct. Bromine undergoes oxidation iodine. That is also not correct, right? Okay. Bromine also undergoes a reduction. Iodine also undergoes reduction. And they are a good reducing agents, right? So answer is A is the correct answer, right? Okay. Yes, everybody. Next question. Very good. A is the correct answer. Very good. Very good. Now let us see. The next question is, identify the incorrect statement here. They are asking you to identify the incorrect statements here. Yes. Right? Okay. I think we are left with only maybe 7-8 questions. Okay. So identify the incorrect statements here. Maybe in next 20 minutes the class will end, right? Identify the incorrect statement regarding primary standard of titrometric analysis. Okay. Titrations. It should be purely available in dry form. They are asking you, okay, incorrect statements you have to tell. Okay. Chalo. It should be purely available in the dry form. It should not undergo chemical change in air. It should be hygroscopic and should react with another chemical instantly and stoichiometry, right? Stoichiometrically. It should be readily soluble in water. KNO4NaOH can be used as primary standard here. Yes, everybody, which of the following statement is correct here? Correct or incorrect they are asking? Incorrect, na? Incorrect they are asking. First thing is, it should be readily soluble in water. That is the true statement, right? It should be purely available in dry form. That is also very, very important, right? It should not undergo, it should be hygroscopic and should react with another chemical instantaneously and stoichiometrically, right? Primary standard of this is not this, so this is the false statement, right? It should undergo chemical change in air. In air, it should go chemical change. It should not undergo chemical change in air. So then that is the correct statement, right? Okay. It should not undergo chemical change. Now, KMNO4 and NaOH can be used as primary standard in the titrations. That is also not true. So answer is, identify the incorrect statement. Na? Incorrect statement they are asking you. Incorrect means C and D. C and E. C and E is in the B. Okay. So B is the correct answer. Right? Okay. Chalo. Next question is, in the acidic medium shows oxidizing action. Right now they are saying that in acidic medium K2Cr2O7 shows oxidizing action as per this. So guys, this is based on the balancing only. I think we have done this before, is it? Have we not done it? Have we not done it? Acha. First, you tell me Cr2O7 is oxidized to which thing? Cr2O3 or Cr3 positive, right? It is oxidized to CrO3 or Cr3 positive. It is oxidized to which thing? We have done this before, yeah? Okay. It is oxidized to CrO3 or Cr3 positive. Cr3 positive, right? So these two things are already eliminated, right? You have this one and you have this one. Okay? Here two things you can do. One, so you can solve this with the exact method. Other is you can just do hit and trial, right? Okay. So I would advise you to do hit and trial, because solving with the direct method, we have done that before, right? Okay. So what you do, you have two options that you want to choose among, right? 14 is same. So just write down this equation. 14 CrO7 2 negative plus X is given to be, X is given to be this, right? Okay, Cr2O7, X is given to be 14H positive, right? 14. Then you have Y is given to be 6. I'll take firstly D. I don't know why I'm taking D, but I'll take firstly D. Right? 6 electrons give rise to 6 electrons. This is 2 of Cr3 positive. This is Z is given to be 6. Z is not given to you. X, Y is given to, Y is given to be 6 here and it is 7. Okay. It is 6, then I'll take this as 7. 7H2. Just see whether this is balanced or not, right? This is oxygen is how many? Chromium is 2 and here chromium is Cr2 only, na? Right? So this is, you can also solve it with that proper method. If you want me to solve, I'll also solve it with that method. Totally your wish. But I would advise you do this instead. Right? Okay. Okay. Understood? Acha. Now here you have Cr2O7, chromium is 2, chromium is 2. Oxygen is 7, 7 and this is 7 and this is also 7 oxygen. Oxygen also done. Hydrogen is 14 here, hydrogen is also 14. Wow. Okay. Charge is 2 plus this is 14, that is minus 6. Right. So this is 16 minus 6, that is 10 is the charge, plus 10 is the charge here. This is 3 to 6 is the charge, right? 6 is the charge. Is it? Here the charge is plus 2, 14, 15, 16, 16 minus 6. So 10 is the charge. So that means charge is not getting balanced here. Charge is not getting balanced, no? This is 6, this is 14, 15, 16. 16 minus 6. So charge is not getting balanced. So I'll rather take it as 7. If I take this as 7, this is 14, this is 7. If I take it as 7 and this is Z is what? Z is 6. Chalo, let's take it 6. Let's take it 6. Let's solve this. This is 14, 15, 16. 16 minus 7 is 9 electrons. This is 3 to 6. Again, it is not getting balanced. Why? Oof. Ma'am is tired, I think. Your ma'am is fully tired. Should be minus 2 here. And then I think it will be balanced by 6 only. If I like, how much I remember, I think it should be balanced by 6 only. This is 6 electrons, right? And this is 7. Let's again solve this. 7H2O. Now let us see. This is 14 minus 8 is 14, na? 14, 6, 7, 8. 14 minus 8 is how much? 6 only, right? 14 minus 8 is 6 only, right? And this is also 6. So yes, D is the answer. Yes, I forgot that there is Cr2O7 2 negative, right? Now, this is a better method, right? If you have options, that oxidation reduction, that is also a method, but if they have given you like full reaction, they're asking the balanced equation. In this case, if you write it, if you solve it, that would be stupidity. Reason being, because you can solve it easily, then why not to apply easy method, right? Okay. Chalo. Next is, now they are saying that which of the following reaction is a disproportionation reaction? Now students, which of the following is a disproportionation reaction? Very, very simple. Copper is +1 oxidation state, it is +2 and it is 0. Oxidation state is increasing, it is decreasing. So this is a disproportionation reaction. So E is a disproportionation. That means this cannot be the answer, right? B, let's see B, if you find out whether D is the disproportionation or not, then this will also be eliminated. Let's firstly find out B, right? So B is MnO4 2 negative. It means it is apna X minus 8 is equals to -2. X is equals to plus 6, right? So it is in the plus 6 oxidation state. Here it is X minus 8 is equals to minus 1, it is plus 7 oxidation state. X minus 4, so it will plus 4 oxidation state, right? So now here it is increasing, it is decreasing also. This is also, B is also there. Now you just have to see whether C is disproportionation or not. Now we know that MnO4 negative is plus 7, right? MnO4 2 negative is plus 6. MnO4 is plus 4. Now here oxidation state is only decreasing. It is not increasing or decreasing. So C is not the disproportionation. So answer will be A and B is the correct answer. Last also you can see this is plus 7, right? Okay. This is plus 7. This is plus 2, right? Acha. This is not disproportionation, this is comproportionation, right? Here it is MnO4 is plus 4. You are getting one oxidation state by the decrement also, by the increment also. So this is a comproportionation. It is opposite of disproportionation reaction. Okay. So this also they can ask you what is comproportionation reaction. Okay. Chalo. Next is which of the following cannot function as an oxidizing agent? Again, oxidizing agent means it should get reduced itself, right? Itself it should get reduced. That means its oxidation number should decrease or increase. Act as an oxidizing agent, that means it should oxidize, it should itself get decreased. That means itself get reduced, right? That means oxidation number should decrease for that. You should decrease the oxidation number for that one. Yes, everybody. Now you just need to find out the oxidation states here, right? Already we can see the answer, right? If you talk about BrO3, let's talk about one by one. This is X minus 8 is equals to minus 1, X is equals to plus 7. Definitely it can decrease the oxidation number. The variation is from plus 2 to plus 7. This is X minus 6 is equals to minus 1, X is equals to, this is 5. It can also easily decrease the oxidation number here, right? Bromine, it exists in plus 5 oxidation state. It can decrease it. This is X minus 8 equals to minus 2. So X is equals to plus 6, right? Again, sulfur is in the highest oxidation state only. It can decrease its oxidation state. Talking about N3 negative, right? Everybody, talking about N3 negative, right? It cannot further decrease its oxidation state, right? It already is existing in the lowest oxidation state, that is possible for nitrogen, right? That is plus 3. It cannot further decrease. At least 3 bonds so it will make, na? Right? So it is already existing in the lowest oxidation state. It cannot further decrease its oxidation number. Lowest oxidation state is existing in. So answer will be A is the correct answer, right? Okay, next question is KMnO4 decomposes on heating. It decomposes on heating at 51 K Kelvin to O2 along with KMnO4, guys, it decomposes on heating to form O2. It along with which of the following, right? You can do elimination also. Decomposes, remember it decomposes, right? So how will it decompose, right? KMnO4, right? It exists as plus 7 oxidation state, right? So K2O2, so there is no scope of that only, KO2, right? Okay, between this and this, I am giving you two options here, right? K2MnO4 and Mn, K2MnO4 and MnO2. Very good. Which is the correct answer? D. Right? It decomposes into KMnO4 decomposes into K2MnO4 and MnO2. This you have done in DNF block as well, right? Okay. This you have done in DNF block as well. Now I think this is the last question because I have kept it as homework for you guys, right? Okay. This is a homework. If you want me to do this, I can do here also. If you want to do it yourself, then I'll just keep it as homework for you. because in this case, no option is given to you. Now, like you think, ma'am, why you have taught us that oxidation half reaction method? Because of these questions where they have given you it's the integer. They are asking the coefficient z value, you need to tell them. Option is not given to you. Now you have to solve it, right? Now you have to solve it, right? Okay. Will you solve it yourself? Do you want to take it as homework, or do you want me to solve? I would advise you to take it as homework. Okay. And answer it in the comment section. What is the correct answer? Answer it in the comment section, and also with which method you would want to solve it. With half reaction method, or 2-3 steps I'll do for you. 2-3 steps I'll do for you. Right? Okay. So this is just take normal. This is MnO4 negative. This is plus I negative. I'm not even taking water. How to simplify this? Don't take this water here. Don't take these coefficients. Okay. Just simply write the equation. I negative. This is MnO2. Don't take this OH negative. Just remember that they are talking about the basic medium. That is why they have mentioned OH negative. Right? That means this is in the basic medium. You have to answer it in the basic medium. That hint is given to you. Right? And here it is I2. Right? Okay. So how do you solve it? Just chalo, theek hai. Very good. Very good. Very good. Shabash. So this is x minus 8 is equals to minus 1. This is plus 7. Right? This is x minus 4 is equals to 0. This is plus 4. This is minus 1. This is 0. Right? Okay. Chalo, because we have less space, I'll just solve it by oxidation number method only. Right? So here you have reduction. This is reduction. This is oxidation. Right? This is oxidation. Okay? This is reduction. This is oxidation. I'll not solve the full question here. I'll solve the half part. The balancing of oxygen, hydrogen, and to convert it into basic medium, that you will do with like your own self, right? Okay, that is your homework. I will not do that, right? Okay, I will not do that, right? This is a reduction. This is 1 manganese is getting converted to Mn here, so it will be plus 7 mod you can take here. Mod you can take here. 7 minus 4, that mod is 2. Sorry, 3, right? Okay, that mod is 3. Now here it is. Here you can take it as acha. Here they are talking about 2 iodines here, because you need to balance this also. This will be multiplied by 2. So here it is minus 2 minus 0, that is 2. Now you need to multiply this 2 with this particular equation. This 2 will be multiplied here, right? So just multiply this 2 here, right? Oi hoy. So this is 2 will be multiplied here. Arre nahi, here it is not multiplied. Wait a minute. 2 is multiplied here, right? And 3 is multiplied here, right? Okay. Okay. Now this balancing I have done, right? Now rest part you will do yourself, right? This is 6I negative give rise to 2MnO2 plus 3I2. Right? Okay. Okay, guys. Now, rest of the part you will do yourself. You need to balance the oxygens here, right? Then you also need to balance the hydrogens here. Then you also need to add the, to make it into basic medium, you need to add OH negative, right? Okay. 2OH. Huh. Very good, very good. But I will not tell you whether that is the correct answer or not. Right? Okay, that you will do yourself. Okay, that you will do yourself. That you will do yourself. So I'll just erase this thing here where answer is given. I'll just erase that thing where answer is given. Okay, chalo. Now I'll wait for your answers in the comment section. I'll wait for your answers in the comment section, that what answer you are giving. Okay? What answer you are giving. Very good, Sanjay. Very good, very good, very good. Very good. Very good. Here you have, chalo, I'll 2 oxygen, 4 oxygen, 4 oxygen, right? Okay. Here if you talk about the hydrogen here, wait a minute. This is 4 na. This is 4 into 2. This is 4 to 8 oxygen. This is 4 oxygen. Here you have 8 oxygen. Here you have 4 oxygen. So that means how much water will be added? How much water will be added? Right, here you will add 4 water, right? Chalo, till water I'll tell you. 4 water is added here. 4 water is added here. Now only 2 steps you are left with. You need to add the same amount of H positive, then OH negative, right? To balance, to make it into a basic medium, right? Okay, that is your part, right? Okay, ji, understood, beta? Everybody understood? Now I'll be waiting for your answers in the comment section, right? Okay, students, now I'll be waiting for your answers in the comment section. And one more thing about all of you. So guys, we have test series going on where we are giving you test series for all the engineering exams, right? All the engineering exam, we are giving you the test series, right? So basically that is for all the state level exams. You will have test series for JEE Mains and JEE Advanced as well. 20 test series you will have for JEE Mains and JEE Advanced, and 10 test series you will have for JEE Advanced individually, right? And moreover, you will have tests like Comet K, KSET, you will have BitSat, VIT, Triple E, right? All these exams, I'm just mentioning 4-5 exams, around 10 to 12 exam that you have that are very, very, very important for you to give, because yeah, we can't rely on only one exam, right? We have to give, because the syllabus is same, right? I would say the pattern will be lower than JEE Mains only, or equal to JEE Mains, right? Not above than that, right? Okay. Yeah, some questions, some parts are complex also, right? That touches, but it will be slightly more or equal to JEE Mains only, right? So that is why it is very important to give, for you to give the backup exams also, right? So each test series will be given to you, 10 each exam will be given to you in that particular test series. Now if you talk about, ma'am, I want to purchase only JEE Mains and JEE Advanced, that is for 1999. And if you want to purchase for other exams as well, around you can say around 10 into maybe around 100 more test series will be given to you, right? Okay, when you give 500 extra, right? So that is for 2499 something is there, right? So at this amount you are getting around 150 something, 130 something test series. That is an amazing deal that you will get here, right? In next 5 months, now you can give the test series for JEE Mains, and after some time you can start giving for state exams as well, right? Then after that you can also solve the questions for JEE Advanced, right? So that is very beneficial if you purchase it right now, because that is at the discounted price because of the JEE Mains, and also that will help you in the upcoming JEE Mains exam, right? Okay, yes. MHT set, okay, all the state level exam and the individual exam by prestigious institutes, right? Okay, chalo. Okay then, beta, bye bye, take care, see you all. I'll be waiting for your answers in the comment section, that what amount of OH negative you will have, right? What is the value of Z? I'll be waiting for that in the comment section. Bye bye, take care, see you all, and happy Sunday, and see you all in the next class. Tomorrow we are taking NTA's favorite questions, right, at 11 a.m., right? We'll be picking the best questions for you, right? And next, in this week, I have two very, very important planned sessions for you. One is full chemistry marathon, right? We will take up some concepts and we will solve the questions, most predictable topics, right? Most important topics only I'll pick up, right? That's a very, very important marathon for your full revision of chemistry, right? And one more lecture I'll take that I want to see in the comment section, right? That is for practical chemistry, that will have salt analysis mainly, right? And other parts of small parts of practical chemistry. Okay, chalo. Okay then.